We started in December of late 2020. And what we do is we focus on a different industry theme each month. So everybody can see my screen now, and we can get started right away. This is the advanced materials and electronics and also semiconductors. Not all that fits into the title. Where we're going to be starting off the evening the evening where we are in the world, but afternoon for where everybody else is in the world. With focusing on an open topic, which is not connected to the industry theme of today. And then we were going to be moving on to our advanced materials session, followed by our semiconductors and electronics session. A little background about who we are. What we are is a business development firm for deep tech startups on the one hand, but we also represent, on the other hand, stakeholders. We'll talk about that in just a minute, where our goal is to advance innovative small businesses with their different solutions and help them to come into market and to provide their solutions to different users of deep tech. What we see is that really through the chemistry of business development with technology development and the innovation, some real things can happen, and the technology that can potentially change our world can actually reach market. And that's what we focus on deep tech, because deep tech has the ability to solve different challenges that we're facing with or we're going to face in the future. And it's really exciting for that reason to deal with the whole industry, if you could call it that, of deep tech. We are a business community for deep technology as well, as being a business development firm. And one of the things we do is we run an ecosystem, which we'll talk about a little bit in just a few minutes, where you have on the one hand innovators that are developing the next generation of technology, and on the other hand, you have the stakeholders. What this means for startups is we give a suite of services that help that startup enter into market, whether it's a government market or private sector market, which includes strategy, which is, I guess, the analogy would be, sharpening your tools before you go into the woods to cut down that tree, and then also make sure you're going to the right forest. Then there's content and design of materials to help the pitch be heard and have the technology and the story behind it to really to make an impression on those listening. We also provide through the network guided introductions to government and corporate tech scouts, as well as opening doors to deep tech investors. And of course, we run events like the showcase, as well as between events, marketing assistance and guidance. For the stakeholders, it's a little different. First of all, we have to define terms. A stakeholder, in our definition, is as it relates to the deep tech innovation and making to market, are those that have the ability to actually help the technology to move forward, to advance. And that includes three major categories of individuals: those from the public sector, those from major corporation, and investors, where obviously each one brings something unique. The public sector, it's probably through pilot contracts and giving the ability to make an impact on a very, very large scale, which is the Department of Defense, which is a huge, huge industry partner, even though it's public sector. Next would be maybe major corporation looking for a merger and acquisition opportunity, or for a partnership with a deep tech startup doing something which could make a higher impact. And they already have the customer base. They just need the additional add-on of that small business technology in order to make that combined product effective and essential. They can also have CVCs, which are making investments themselves. And then, of course, investors provide the capital. For the stakeholders, we offer the ability to uncover or discover, identify great startups that are within our ecosystem, but also from outside of the ecosystem. And that's actually something new that we've opened up as of late, which is tech scouting, deep tech startups that are based in the United States, Europe, and Israel. And also what we do is we try to make sure that those startups that come to the stakeholders, they are more buttoned up. Today, you're going to be hearing from technology companies at different stages of development, and different stages of investment, and different stages of traction as it relates to the private sector. But you're also going to be speaking to startups that are at different stages in this journey about market discovery. And one of the great things we realize is that getting the opportunity to hear feedback from stakeholders, even though maybe that's a little early, or maybe it's just the right time, it's really important and makes a great impact. The reason we need a deep tech ecosystem is because the fact is that stakeholders are inundated with different tech companies, not all of whom are deep, and that just want the influence, want the capital, want the pilot contracts that the stakeholder can offer. And therefore, what happens is that gate gets blocked up, and it's really hard to decipher and to identify a really unique startup from amongst the crowd. But also the innovators themselves might struggle because maybe a lot of the capital that they had from their family and friends, or from initial investments, or even later stage investments, went to technology development, but it didn't necessarily go to business development. And that makes it harder for us to hear them. So it's a question of, first and foremost, allowing for them to be heard, but also on the second stage is to allowing them to turn up the volume. And of course, it takes a village. And that's why it's really important to have the different parties, the different gatekeepers within the deep tech community, to put them together in the same virtual room. Way we work with startups are a number of different brands that we have under our Deep Tech Showcase group. Of course, the Showcase, which is a community, as much as it is also a way to help identify and provide introductions. With Kissing Frog Studio, which is our studio team, helping companies with their pitches and helping them to make the visuals accentuate the story that they have to tell. Deep Tech Capital, which helps with investors finding companies and for companies finding investors. And Deep Tech Strategies, which is as it sounds. What we look at is there are three axes of opportunities for the deep tech startup. That's venture capital, that's corporate partnerships, and there's government business, which splits into two parts. One is on the non-dilutive side, which we don't do directly, but our sister company, Eagle Point Funding, is a grant consultancy that helps companies access public sector capital, which is earmarked for research and development, and contracts and pilot contracts, which are there for a startup or a more advanced startup to engage directly with government. For strategy, we help the companies have a better understanding of new verticals or the existing vertical in order to enable them to maximize it. But also, we want to make sure that when they're approaching the market, they have firm understanding, so that when they have a later meeting, let's say with an investor, well, they have tried and tested their market understanding, but they've also tried and tested their business model. And later stage, that can also lead to a go-to-market plan. Studios is as it sounds. You got to go from technology to story, which is not an easy thing to do. Many companies struggle with this. I know I've experienced that struggle in business. Everybody has. And so you need somebody to come and help you refine your pitch and tailor your pitch, whether you're speaking to one industry expert or another. Of course, there are the events themselves, which this is one of them. And this is what our schedule looks like. We're going to be releasing our schedule for 2022. But as I said, this is already our 9th showcase of the year. And we have the materials and semiconductors, and next up will be aerospace and defense. The package, as we put it together, we work with companies typically on a 9-month membership, where we offer our full suite of services in order to get the real unique technology, the spotlight that it deserves. This is our team. My name is Josh Barone. I probably should have said that at the beginning. I'm the Managing Director of Deep Tech Showcase. And joined on the call is Asher Rudensky, who's the Director of Operations. Yuval Herman, who's the Director of our events. You've probably heard from both Yuval and Asher plenty in the last few weeks. Aliora Moore, who's our Marketing Director, is also going to be joining a little bit later on. So that's our topic for today. Starting with an open topic, moving on to the advanced materials, and then last but not least, our electronics and semiconductors session. Next showcase coming up next month on October 28th is the aerospace and defense focus. We have an open topic as is our tradition here, followed by aerospace, focusing on a variety of aerospace related technologies, and then defense, which is all technology which supports the warfighter. It's important to note here, we won't be focusing on, offensive defense technology. We'll be supporting on defense as it relates to the word itself, as well as supportive technology such as AI and supporting systems. Let's meet our panelists, and we'll drill down a little bit more in a few minutes. We're joined from Next 47, Lydia Dervysheva from Cityside Ventures, Daron York, from Sierra Nevada Corporation, John Reifenberg, Miranda Waugh from ZF Group, from J Ventures Fund, Nilesh Trivedi, and Cassandra Carruthers from Upheaval Investments. The companies pitching are going to be Thermovent Technologies, Flash Scientific Technology, Sensorlink Corporation, and Cyber Infrastructure Technologies. After that, we're going to have our advanced materials panelists, and we'll introduce the panelists and the companies ahead of each session individually. The last moment on our network, we're part of a larger network which helps deep tech companies in a variety of versions. One is on the government R&D funding, which I mentioned before. That's Eagle Point funding, but it's also Argentum, which is focused on helping EU companies from the EU and also associated EU countries to access funding through their systems, such as Horizon, and Eagle Point funding, which helps companies access our R&D funding from the US federal government for technologies outside of the life sciences. We also run some unique programs, and one that I wanted to just mention today is called the MOU Club. For anybody on this session which is familiar with the AFWERX program, we run a specific program which helps companies with going from phase 1 to phase 2, and a critical component of that is accessing a signed MOU from a Air Force stakeholder. Companies in our ecosystem, as you can tell, are at the cutting edge of technology today. And they have the ability to not only just operate on multiple markets, but also access funding from multiple different sectors. And that's what makes this very interesting. What we call dual use, which means government as well as private sector application. And that leads to also unique programs such as tactical funding, or TACFI, or strategic funding, also known as StratFi, AFWERX, and other public-private opportunities where private sector dollars and public sector dollars are used to propel a company forward. Please feel free to contact us. That's Yuval, director of our events, email. Mine is josh@dpecshowcase.com. And you can also check out our website for future and upcoming events. Okay, so we're going to get started with the first session in just a number of minutes. I just want to remind for the panelists, please keep your cameras on. Same is true for the presenters. And what we're going to be doing is do a 5-minute pitch, which is followed right afterwards by 5-minute Q&A. So Asha will let you know if you're on time or not, and we'll get started right now. Yuval, you want to queue up?
Hey, Jason, you here?
I am here and ready to go.
Perfect.
All right, we ready?
Go for it. All yours.
Right. Okay. Good afternoon. My name is Jason Deese, founder and CEO of Flash, where we save lives and economies with weather analytics. Now that's the official tagline. The really cool one is, we predict lightning. Next, please. So how do we do it? Well, in the past, the weather enterprise used hardware for advancement. Before satellites, we could not predict hurricanes, and then prior to radar, we could not predict tornadoes. But these hardware solutions have severe limitations, such as reliability, data gaps, and most important, they have a limit on the real-world problems they can solve. So welcome to the future, where Flash uses software-only solution to take algorithmic insights, AI, and machine learning, and combine this with vast data lakes to solve the previously thought unsolvable. We started with lightning prediction. Hardware-based networks only show observed strikes, meaning they miss the all-important first strike 100% of the time. This is important because 40% of all injuries and deaths come from that first strike. Next, please. We also started with lightning prediction because lightning is a big problem getting bigger, as you can see from these numbers here. 22,000 wildfires started per year. I'm sure you've seen the $1.8 billion in losses in California this past year. 240,000 individuals struck, that's worldwide, and we will have a worldwide solution. $5 billion in insurance losses. So think about your high ticket items. A $250,000 piece of equipment. Studies show that if we cut the power to that prior to a lightning strike, we can greatly mitigate the damage to that piece of equipment. And then the one we're perhaps most excited about is the aviation sector. $1 to $2 billion in losses every year due to lightning alone in that sector. And I'll tell you in a moment why we're excited about that. Take all of these numbers and keep in mind that lightning frequency will increase by 50% through 2100 due to climate change. So all these numbers will be increasing. Next, please. So what do we provide? We provide the start of lightning. We have 15 to 25 minutes prediction lead time on that first strike. No hardware needed. Unlimited monitoring radius, so we can go across the entire United States and ultimately the world. Prediction accuracy of up to 99.6%. We have a patented algorithm, the patent has been issued that predicts the first strike with high accuracy. We focus on the first strike before a storm ever develops. But wait, there's more. Next slide, please. The same algorithm used to predict the first strike is used to predict the last strike. So right now, the technology is dumb as you can get, and I'm sure you guys have seen it. 30 minutes after the last rumble of thunder is the current practice before you can resume normal activities. At Flash, we feel we can safely cut that time in half so we can resume normal activities sooner. So think about the aviation example. Remember this statistic. The Boeing jet burns a gallon of fuel per second circling a runway. So we did pricing models with Southwest Airlines. If we can get those aircraft down safely just 5 minutes faster or in the air 5 minutes faster, then they're saving hundreds of millions of dollars a year in fuel costs alone, and that's just for one airline. Next, please. So what kind of traction do we have? Well, we participated in the Miami condo collapse. We were asked to give lightning forecast for that. We provided lightning forecast to rescue crews for a 5-day period after the collapse. This included the challenging forecast for the approach of Tropical Storm Elsa. We even got a shout out on CNN for the services we were providing. We also, this past month, participated at the Daytona race. We provided lightning forecasts for public safety of race attendees. We did have lightning that came on shore, and so we alerted race officials to that. We also provided DGM race team with accurate forecasts of the onset of precipitation to aid race strategy. So again, not only are we just doing lightning, but we're using our AI machine learning for other aspects, which I'll show you here in a second. And then at the bottom, high-level talks with numerous airlines and Gulf entities, really anything outdoors, but starting with the enterprise customers, which would be the airlines primarily. Next, please. So our AI machine learning framework allows for easy integration into a variety of industry-specific needs. So not only are we doing lightning, but we already have an automated tornado product that actually goes out and detects tornadoes. No humans needed for this, issues tornado warnings, and already rivals that of what the National Weather Service for their statistics issues. Wind, think about fleet management, precipitation, onset of precipitation, and then hail, hurricanes, and winter storms, all from this AI machine learning. Next, please. So the product you'll see in the upper left, the yellow and the red indicate the predicted lightning strikes far in advance of a storm. And then on the upper right, you see our tornado prediction algorithm. And then on the bottom is the onset of rainfall there at the Daytona race. But these are all just for you guys to see. At the end of the day, we are just going to be an API provider, data provider, lightning and severe weather prediction services across the entire world with no hardware requirements. Enterprise and consumer software lends itself nicely to integration, and then an agile infrastructure with a robust Redis and Lambda infrastructure for big data. We're going to use this AI ML integrations for tornadoes, winds, winter storms, and hurricanes. Next, please. So the ask, we raised over $1 million in Start Engine, which was crowdfunding in 6 weeks. That was the top 10 all-time and fastest raised for $1 million on there. We're currently in a Regulation D, having raised over $460,000 of $2 million, and this round is at 30 cents a share. Next, please. And so I'll be happy to take any of your questions at this time.
All right, opening it up to the floor. Go ahead, Nilesh.
Yeah, what is the underlying data that you use? Can you maybe help explain or understand what data do you utilize to get your algorithms and the predictions?
Yeah, we're using a whole host of big data. So that would be radar networks, satellite networks, observation data. So we are on the underlying using a variety of hardware networks, but it's all feeding into our software solution.
And you get that by virtue of your partnerships, or is this in public domain?
Yeah,
How do you?
Yeah, that's the beauty of it, is it's all publicly free. You know, already been paid for by the taxpayers, and so yeah, we haven't paid for any data. It's just all out there for free use.
Okay, awesome. Thanks.
Cassandra, I think you're up next.
Sure. Thanks, Jason. Great
Well,
overview.
A small thing I forgot to mention. Can you just introduce where you're from, at least in your first question?
Sure thing. I'm from Upheaval Investments. We're a Chicago headquartered generalist deep tech fund investing early stage anywhere in the world, hardware and software. My question was just to learn a little bit more about how you're making money, the business model, and the go-to-market plan.
Right. So the go-to-market plan right now is to target the enterprise consumers first. We have talked to several weather entities that have done it the other way, and it's cost them. So if you come out with a consumer app, then it's harder to sell to the enterprise consumer. So, you know, we have a variety of ways to go about it, but we feel this software as a service and just feeding into the airlines, insurance, energy sector, utilities. We're excited about that. They reroute high power lines based on the weather, so we can make that more efficient. So enterprise consumers first, and then just selling that as a licensing product.
Thank you.
Awesome. Lydia.
Yeah, hi, I'm Lydia. I'm a partner at Next 47, which is the venture arm backed by Siemens. We invest in B2B startups across the world. So thanks, Jason, for the presentation. So I had a question on basically how do you integrate with your customer solutions? Is it an API that you provide, or how do you actually give them the data whenever there's a lightning like information that you need to share with them?
Yeah, right now it's an API. We actually are dealing in a lot of big data for the API, so it's almost rivals something like you would see with a gaming solution like Fortnite and stuff. So a lot of our initial development's gone into the streaming technology and allowing that API to support that, which we've done. So, but yeah, we're trying to be as agile and flexible as it can be so that we can integrate with as many partners as possible. So API is the way to go.
I have a question. This is Duane York from Cityside. Given that you're pulling data from, you said sources that already got paid for, so public domain, so to speak, what kind of IP protection do you have?
Well, the IP protection that we have is on the algorithm and the process that we use. And so, you know, there's nothing proprietary about the data that we're using. It's just in the way that we're using it. And so the process and the actual algorithm itself is unique. And so we have protections on those. So
did you file patent on those?
Yeah, that patent has been issued. It was issued in 6 months because there wasn't really anything like it. So it was issued very quickly.
Okay.
Just a quick question. Oh, I'm sorry, just a quick question. So does your solution predict the dry lightning? This is a big concern in western part of the US. So just wondering about that.
Yeah, it does. So fortunately, our solution, it doesn't depend on what's going on at the surface. It actually looks aloft higher into the atmosphere. And so it doesn't matter if any rain's coming from that, the dry lightning, it can detect it just as well.
Okay, thank you.
Awesome. Thank you so much. Please stay around because you have a bunch of questions in the chat. You can and also share any information you like, your contact information within the chat. Thanks for joining us.
All right. Thank you so much.
Next up from Cyber Infrastructure Technologies is Harris Masick, who is founder and CEO. Hi there, Harris.
Good day, everyone. My name is Harris Masick, founder and CEO at Cyber Infrastructure Technologies. We are a spin-out venture from the University of Utah focused on cryptography and communications. Next slide, please. Security is one of the major concerns of modern communication systems. And with cyber attacks growing in size and sophistication, There exists an ongoing need for ultra-secure communication technologies to uphold secure, accurate, and efficient data transfer. Next slide. So far, we have been operating as an advanced cybersecurity laboratory, translating the latest advances in signal processing and communications technology into solutions for enterprise and government. We've been committed to the development of scalable data assurance technologies for the ever-expanding Internet of Things, and we focus specifically on data acquisition. Next slide. For traction, we are a proud recipient of a U.S. Air Force STTR for dynamic systems mapping and analysis. We're also part of two accelerators, the University of Utah Company Launch Program and the newly formed Quantum Startup Foundry at the University of Maryland. We've also partnered with the NATO SPS Quantum 5 team and Flux Research Group at the University of Utah to develop solutions for securing data and transmission. Next slide. So what is the technology? Well, data transmission is no stranger to packet loss. But what can you do when the missing information is vital? The technology we're developing with the Air Force tests the continuity of data packets and predicts, based on what came before and after a signal, what information is missing or garbled. The tool could be used for debugging, data analysis, or error detection for all types of transmissions, including facsimiles and analog to digital conversions. But our current focus has been on applications related to data acquisition systems. Next slide. Glancing at the data acquisition systems market, there's a few key takeaways. One, the market is quite small at $1.8 billion. Two, the market is primarily driven by R&D in the aerospace and defense industry. And finally, this makes it a fitting niche for our work, enabling us to concentrate our marketing efforts at the DoD. Next slide. For intellectual property, we have an exclusive patent license with the Army Research Laboratory for a non-line-of-sight optical communication scheme, and 6 non-exclusive research patent licenses with NASA. The top 3 patents plus our own relate to optical communications, while the bottom 3 relate to nonlinear signal processing. We had plans to further develop the quantum technologies and tackle challenges of distributing entanglement, but have shifted our focus back to traditional communications after some discussions at the Innovari Aspire Summit with the Air Force Research Laboratory. Next slide. We currently have 4 services: modeling and simulation of communication networks, including QKD, integration and testing of QKD with existing telecom infrastructure, network organization solutions, and network management. These all kind of fit under the umbrella of research and development at this time, but we could offer it to enterprise as well. Next slide. For SWOT analysis, we have our strengths with an access to network test beds thanks to our academic partners, optical communication, signal processing IP, and telecom know-how. We have an existing contract with the Air Force Research Laboratory through AFWorks. For weaknesses, there's difficulty in finding good talent, and we lack a personal laboratory, which results in anywhere from 30 to 60% of our R&D budgets being allocated to research institutions. For opportunities, there's plenty of federal R&D funding for communications technologies and the upcoming Quantum Investor Summit at the University of Maryland. For threats, we have Amatech, Teledyne, and Signalscape. The first 2 are the larger players in this space, and they're mostly focused on hardware. Signalscape bears the most resemblance to us at this time, but they've struggled with scalability. Next slide. Today, we're looking for corporate partnerships in the form of R&D collaboration or letters of support, an MOU from interested DoD stakeholders, and we're also looking to start conversation with interested investors. We're currently raising $750,000 with resource matching being provided by the University of Utah and Air Force Research Laboratory. Next slide. Taking a look at our roadmap, you can see the company was founded a little over a year ago. We're currently focused on securing 1 to 3 R&D grants or contracts and plan to pitch at the Quantum Investor Summit come October. We've also recently attended the Innovari Aspire Summit and will be establishing a collaborative research and development agreement with the Air Force Research Laboratory. For 2022, we'll begin development of scalable signal analysis technologies with the AFRL and hope to get a simpler product released by the fall. And finally, in 2023, we'll begin testing and evaluation of our prototype with the AFRL. If all goes well, the work will translate to an OTA contract to help resolve warfighter needs. Next slide. For our team, you can see myself as founder and CEO, Dr. Miralem Mehic as our telecom research scientist, and Dr. Miroslav Voznak, our signal processing lead. Next slide. Thank you. I'm open for any questions.
Okay, open up the floor. Nilesh, I think you're first up.
Yeah, let me introduce myself. I'm Nilesh Trivedi from the Bay Area. We are sort of a stage agnostic and a sector agnostic fund, mostly funded by close to about 400 investors across the board, founders, VCs. They all invested in us. We are sort of a community-based fund. My question, Harris, is what is your business model? You basically want to license the IP, or you want to, some of this is all protocol based, as far as I know, routing companies, for example. So I'm kind of curious, how will you actually get your technology into your customers' hands?
You're right. And that's why we've actually been functioning as a sort of cybersecurity laboratory since our inception in 2020. But that's why we're planning, especially for 2022, to integrate the technology we've already developed into a sort of scalable middleware solution. Especially with IoT, having a middleware solution integrated with sensors, you can start standardizing the data. And data heterogeneity is a huge problem with IoT. So having a sort of scalable data acquisition system, it would be a really good way to scale the business model. I hope I answered your question, but I could dive into more details if needed.
Okay, sure, thanks.
Go ahead, John.
Yeah, John Reifenberg. I am Director of Technology at Sierra Nevada Corporation. We are the largest privately held aerospace and defense company in the United States. My question is, and forgive me, I'm not that fluent in this type of technology, but my question is, can you provide a tangible example of how a defense customer might use the product that you're offering or the services you're offering?
Yeah, so at the Innovar Aspire Summit, we actually had the Air Force Research Laboratory lead for our challenge problem. And they basically described the issue with they're collecting radio signals, and they want to ensure that these radio signals are accurate before acting on that information. So what we do is essentially just scour the signal, look for any missing or garbled information, and correct that, or at the very least detect it.
Okay, thank you.
Go ahead, Cassandra.
Yeah, thank you for the presentation and all the information. Cassandra Crothers from Upheaval Investments. I was curious, what actually are you building at the core? I heard you mention a prototype, so I'm wondering if there's hardware innovation involved, or if it's off the shelf, if it's heavily software, and or if it's heavily services.
I think I did mention, we put the optical communications hardware stuff on the side now, especially because we had this Innovar Aspire Summit recently, and the Air Force specifically wants to partner on developing a software solution. So this is what I'm talking about with middleware. It's essentially software interfacing with the hardware components. So we have the sensors that collect the signals, and then our software will look at those signals and correct any errors, or at the very least detect those errors before then it goes to the operator. They can act on that information.
Got it, thank you.
Go ahead, Lydia.
Was curious to hear, hi, I'm Lydia from Next 47. Curious to hear more about your kind of the timeline of development, kind of the roadmap of the product. Kind of when do you expect to have like product in the hands of customers and actually get revenue, so like significant revenue?
So the core technology has already been developed and evaluated by the University of Maryland as well. So we have a support letter documenting that. The main issue is now just integration with sort of more accessible solutions. And that's why I really focus on middleware, because I think that's where the main focus will be. And I'm hoping to get the product out by fall of 2022. But the CRADA is going to last for probably 3 years. So I'm not entirely sure what kind of developments we're expecting throughout the whole 3 years. But I hope that we can get some major product development done in the first.
Okay, awesome. Any last questions for Harris? Okay, thank you very much, Harris.
Thank you.
Up next is Gary Hilkema, who's the president of Sensorlink. Gary, are you there?
Yep, I'm here. Can you hear me all right?
Perfect.
Awesome. Well, hello, everyone. And yeah, I'm Gary Hilkema. I'm representing Sensorlink today. And I just want to thank you all for this opportunity. Next slide. So we have a vision, and it's based on the changes that are occurring in the world. And we want to aid the electric utilities in protecting their revenue and adapting to new market demands. And they have a serious challenge ahead of them. Next slide, please. The challenge we have identified as the one to create an opportunity from, as stated in the research by Z Prime, is 90%. Over the next 5 years, 90% of the utilities will have integrated renewables, but 2/3 are dissatisfied with their grid measurement data quality. I've also listed some of the integrated renewables that play a big role here are in the changes that are going to occur for the utilities. Next slide, please. So let's put some dollars to the challenge. Just overall, it's estimated that it will cost the utilities up to $1 trillion to update the distribution grid for solar and electric vehicles alone. Next slide, please. So what is the need we want to resolve? We want to get, oh, I see the slide slid in there. Those are some questions that the utilities are going to have to deal with: where to begin, how to know where to update, and what needs to be updated. Next slide, please. So what is the need we want to resolve? We want to get the utilities the data they need to substantiate their plans, and being able to do that in a very pointed way. Next slide, please. So our solution, and we realize it's just a starting solution for the utilities, is to monitor distribution transformers. And our approach is using a low profile sensor, provide data at the source, and to make key planning decisions for overload prevention, theft detection, and power quality. Next slide, please. Our core technology allows us to do this, and it starts with our Rogowski Coil. A Rogowski Coil, which measures current, allows for a wide bandwidth, cannot be saturated, and is very accurate. Next slide, please. And based on our research and expertise, we designed this sensor to be live lined installed within 5 minutes, weighs less than 1.5 pounds, and is difficult to visually detect from any distance. Next slide, please. The final piece of our core technology is the electronics, which is our measurement board, and we've created some room for integration with third-party technologies as well. Next slide, please. So the final product all coming together is called the TMS XT, and it takes our core technology along with cellular communication for transmitting data, with options of simple software retrieval or integration with enterprise solutions. Next slide, please. Market potential is based on the number of existing transformers to be monitored in areas where the DERs will be installed. So based on potential gigawatts to be installed by 2025, it is estimated to be about 2.3 million transformers could be monitored for upgrades to happen. Next slide, please. So Sensorlink, well, we have the sensor, the technology, and what we're looking for are technology partners to integrate communications, to develop a way to make the data get to multiple data platforms, and some simple software. We're also asking up to $1 million to be used for finalizing the development, releasing the manufacturing, and commercializing the product worldwide. Next slide, please. We have worked with companies in the past in developments. These are a list of some of them. Next slide, please. There is some competition. A couple of the products, the Grid 2020 and the AGI LV node, are two types of systems that go on to existing transformers, though one is put on a transformer itself, the other on a pole, and very highly invisible, very visible, and time consuming. Next slide, please. So our advantage, price is going to be important because the utilities will spend money We're going to need to spend money to wisely spend a lot more money. And our ability to be accurate with discrete sensor, as well as combine the cost of our installation and the per unit cost, is going to be much less than our competitions. And we also have the ability to partner with other integrations. Next slide, please. Just a little bit more on Sensorlink. We sell throughout the world using distributors and manufacturers reps. And this map just shows where we've sold to throughout the world. Next slide. We have over 42,000 units of our flagship product, the AmpStick, as well as other products that we sold into 83 countries. Next slide, please. We have an incredible team made up of engineers and marketing and VP of operations. We've brought products into production and released it throughout the world. And they're all done here in Ferndale, Washington. Next slide. Thank you very much for your time. And I'm open to questions.
Great, let's start with Lydia.
Thanks, Gary. So quick question about basically understanding, is this something that the utilities already have a budget for and you're taking up some of the existing budget? Like, is it RFQs or RFPs that you're winning that they're already putting in the market and you're winning against other competitors? Kind of how is the process of winning those utility contracts?
Yeah, right now, this is probably falling under the line of less RFQs right now and more in line with operations. And at least starting out there, we're foreseeing it going to more RFQs possibly as they start building out some of these upgrades. But that's a great question, Lydia. Right now, we're not seeing them in RFQs, no.
Awesome. Any other questions for Gary? If not, I have one. I'll start with mine. If any other questions come up. Gary, you're selling across the world, right? So where's your biggest need if you're able to access that level of a global network? Well, what do you want to do further business-wise?
Could you repeat that? You kind of broke up. I apologize.
Yeah, sure. I'm saying it looks like you're distributing across the world, right? Really incredible. That was an incredible slide that you shared with us. What are you looking to do business-wise at this point, considering you've developed a pretty robust network?
Yeah, so we want to utilize in our sensor technology. And we feel there's such an amazing need throughout the world and all the studies done with the utilities that our sensor can be such a great tool for the utilities to use to get the data they need. And so we want to build out our sensor technology, integrate it with other companies' technologies and softwares to get them the data they need to make decisions throughout the world. And so, Asia is a great market for this product. Central South America is another one that is just really booming for needing data to manage their distribution transformers as well as their systems.
Awesome. Thank you. You have a question?
Yes, please. You are Weiser from Next Gear Ventures. Are you selling only the hardware product, or is it only also services on top of that, added services, etc.?
Right now, it's just the hardware. That pricing was just the hardware. The services we would love to partner with some people on, and the services also can be the utility themselves if we are able to create some APIs to bring the data back into a utilities system, data management systems, and what they have in place.
Thank you.
Yeah.
Awesome. Okay, so if there are no more questions for Gary, thank you so much for joining us.
Thanks, everybody.
Problem. Next up and last for the open topic is Thermament, and presenting will be Joe Boswell, who's co-founder and CEO. Hi, Joe, are you there? We'll wait for Joe to unmute for a second. we have Joe on the line?
Can you hear me now?
Now we can.
Excellent. All right. Well, thank you for this opportunity. I will do a quick introduction to our team, technology, and business plan. And I will note that the primary purpose here is to introduce potential investors here and the first institutional round that we are raising. So that's the audience I'm most directing the conversation towards. So we can move to the next slide, please. So this is gonna be a short, quick. I'm gonna try to run through a lot of material in just 5 minutes. So let's get going. Next slide, please. Great. So the reason we exist is because about 12 years ago, I met with the now head of the Mechanical and Aerospace Department at the University of Missouri. And we were looking to develop a solution to this problem, that we live in a world of ever accelerating technology. Microchips are getting smaller and faster. Lithium-ion batteries are becoming more power dense and being put into ever more compact vehicles. And this is allowing for greater capabilities. But if these higher power densities are put into packages that run hotter, which they inevitably do at higher power densities, then a lot of the benefits that we're striving for are offset unless cooling solutions evolve apace. Next slide, please. And so our primary initial target market that we are serving today are the aerospace and defense companies, where they're looking to put higher power density laser diodes, lithium-ion batteries, microprocessors, et cetera, to meet their mission goals, but they're thermally limited by status quo technologies. Next slide, please. So we are an ISO AS9100D certified provider of the oscillating heat pipe technology. We provide thermal mechanical structures. Most of the work we do today is highly custom for a specific satellite platform or radar system or lithium ion battery packaging for a certain platform. But what is unanimous across all the work we do is our customers are looking to raise the amount of power, either watts per square centimeter from a chip or watts per kilogram from a platform, and do so with minimal size, weight, and power. And that's what the OHP technology enables that is otherwise unavailable. Next slide, please. For those of you who have more questions, I'll walk through our background more thoroughly, but we've primarily been sustained as a business with over $20 million of SBIR and DoD or NASA R&D contracts. Our first award was from the National Science Foundation in 2009. We had our first really breakthrough commercialization event in 2017 when the Air Force and Boeing launched 3 experimental OHPs on a Falcon 9 rocket on the X-37B space plane called the Assets 2 launch. And since then, we've done commercial satellite, military radar systems. We've got some other military satellite systems that we're putting OHPs onto, and we are growing rapidly. Our management team is almost all engineers, as you can see, including my co-founder, Dr. Ma, who literally wrote the book on oscillating heat pipes. Next slide, please. We have we're about 50 employees today. About half of us are engineers, the other half are either in the administration or manufacturing. We're relatively vertically integrated. And then we also have a very strong advisory board from the aerospace and defense world. Next slide, please. The OHP is probably a little too complicated to describe on today's call, but just know that it is a heat transfer mechanism that is made by forming microchannels in the hundreds of microns, up to 1,000 microns at times in diameter. Often we have tens of thousands of millimeters of length of these channels inside our parts. They're hermetically sealed and partially filled with a working fluid or refrigerant. So it's a fully sealed device. They often look just like a piece of metal. If you were to pick them up, they'd be slightly lighter, but they have heat transfer rates that are hundreds of times higher than the base material. Next slide, please. Go ahead and hit start on this one. Or, So this is giving you a quick illustration of what, if you look inside of a part of ours, this is how the fluid is oscillating back and forth between heat sinks and heat sources. And so it's actually, this is a glass lidded oscillating heat pipe that we made for the Air Force. And you can see the heat transfer in the device through the fluid that's contained inside a meandering microchannel pattern. Next slide, please. What's unique about OHPs compared to other passive heat transfer devices is not only their extremely high heat transfer rates, but we can build them in a wide range of materials, from silicons to metals, ceramics, and we can make them in 3D shapes and sizes. The primary benefit is that they are both structurally and provide structural integrity, lightweightness, and extreme thermal capabilities. Next slide, please. Oh, next slide, please. Oh, can you all hear me? All right, great. And this just gives you a quick example. Oh, one more back. These next two slides, I don't want to spend much time on. These are really more for reference for folks who are interested. But to give you a sense of performance, we took a unit that's about 1 meter long, embedded it with an oscillating heat pipe, and compared it to a solid piece of aluminum. And you can see it's about 150 times more thermally conductive and about 33% lighter. And so this is used in all types of aerospace and defense platforms. Next slide now. And we have quite a bit of IP. Having pioneered this technology, we have both the empirical data, we have the proprietary software and modeling tools, so that customers who come to us, we can provide them exact cost, timing, and performance specs prior to ever having to prototype. And this is, when you saw that first slide and why we've spent $20 million plus on R&D, it's being able to develop these capabilities and IP. Next slide, please. I'm going to go through these next several slides very quickly because I think we've already used up the majority of our time. So real quickly, one more slide forward. OHVs are useful into a giant market opportunity, right? The heat transfer world, depending how you look at it, kind of covers everything from transport to clothing and more. But because our relationships exist in the optoelectronics and aerospace and defense world, we're going to spend the next 5 years really reaping what we've sown there. And generating revenue and profits in that world. But we are shifting our research and development towards these larger verticals. Next slide, please. And we are targeting a $60 million revenue business. We have $30 million in our pipeline for 2023 from existing contracts in the aerospace and defense. But as we continue to grow with our key customers, we expect that to be $60 to $100 million business per year. The real question is whether this technology can transform, become more affordable and be applicable to the vehicles, IT, industrial markets, medical markets, what have you. And that's where our current R&D is shifting from the core technology into process. Next slide, please. We'll skip this. Next slide, please. Next, I think we should, if people are interested in case studies, we can go back to this, so we'll keep going. And I think I'll end here. We've raised about $3.4 million of equity and convertible debt in our history. I guess we've been primarily funded by SBIRs and government R&D work, but we are raising our first $5 million round of outside financing. We have about 15,000 units that are going to be produced over the next 2.5 years, generating over $25 million of revenue just from that one large contract. And so we're investing in infrastructure and manufacturing as we go through this pretty rapid growth cycle. We also have been selected for U.S. Air Force Mantech to allow us to move into more affordable manufacturing processes. So if you're interested in this institutional round of financing, please contact me or our Vice President of Finance, and then I will open up to Q&A.
Awesome. Thank you very much. I think Neelach has a question.
Yeah, what does your sales process slash sales cycle look like? Can you help me understand that?
Sure. The pros of our sales process is that it's targeting high value customers, Raytheon and Lockheed or NASA, right? But it is a slow process. So it's taken us about between 6 months and 3 years typically to go from prototyping and qualification into production for spacecraft or military systems. That's partly because there's no heritage processing heat pipes, right? They don't exist in any other products. We're the only providers. And as a small business in mission critical systems, it is a relatively slow process to buy down the risk with our customers. That's accelerating now, but it's a relatively long process. Now, the good news, that's bad news. The good news is that we are sole source supply. So having the technology and these relationships and having the qualification for our materials and processes with the major aerospace and defense companies makes us very sticky, but it is a slow process that we're hoping to accelerate.
And one more question on that. So where do you get involved in, with your customers? Is it post productization, or you have to get involved in the design process? Where do you get involved with your potential customers?
So we don't do build to print. We do custom design work. So a customer comes to us, say it's one of your top 4 defense contractors. They'll come to us because the existing solution is overheating or too heavy. And so they come to us to first engage typically in a design process, in a simulation study. And then that's the first stage. And if that succeeds, then that's a gateway into hardware. that we then build in-house and deliver to them for their own testing and qualification. And then that's the second gate. And then the third gate is that succeeds, and they release this into production for a flight opportunity or a fielded military system. So almost all of our work, to answer your question, starts with design. But it's because this hardware doesn't exist until we make it for our customers.
Okay, thanks.
Yeah, you're welcome.
Go for it, John.
Hey, Joe, this is John Reifenberg from Sierra Nevada. It's nice to see your progress. We actually met when I was VP of R&D at Alphabet Energy. I have two questions for you. One is in your government business, how do you plan to transition? It sounds like most of your funding has come from R&D dollars, but the real way to make money in government is with procurement dollars. So do you have a plan to transition from R&D over to procurement? What does that look like?
Sure. The fourth quarter of last year was our first quarter where we transitioned to greater revenue sources coming from procurement than it did from R&D contracts. So we made that transition last year, and it'll be probably about 60-40, 67-33 this year. And then our current pipeline of business has us about 80-20 procurement versus R&D contracts by 2023.
Great. And then if I can, one other question, unit economics for the commercial market. Have you considered that? Because I imagine they'll have more alternatives and be more cost sensitive than your aerospace and defense customers.
Yeah, spot on. That's what the this Mantech affordability work is going to be targeting. But most of our, even in the orders of thousands of units for aerospace and defense customers that we're working with now on the high end of volume for us, are between $1,500 and $2,500 per unit. So, high value. We've got a RFQ from an automobile maker recently for 2.5 million units a year. And, I jokingly said back to them, well, that would be about a $3 billion per year purchase order then at our current price structure. So obviously they're not looking to spend $3.5 billion per year on heat sinks. And that's where we've got to bring our cost quantity pairs, right, as quantities go up, because the demand for this technology is growing into these new markets for electronics and electronic vehicles and IT, but the cost structure doesn't support sales into that market yet, right? So we are working on ways of embedding the OHP technology into metals at a roughly 10x lower cost per unit to enable growth into these multi-billion-dollar markets.
And do you plan to manufacture those yourselves or to work with partners? Will you need the capital to scale that production?
We will, yes. I think for domestic supply, we want to be vertically integrated here in the United States. The automobile market, I think we can serve domestically. I think if we get into the electronics cooling market for mobile devices, it's going to be very hard because ultimately, right, we're selling into the ODMs and OEMs, primarily in Asia. So one of the big focuses for us over the next 2 years is to develop the IP, right, in these low-cost manufacturing processes, build the initial production cells here, front end, back end, and then determine whether or not we can use our IP to partner for manufacturing overseas in the bigger electronics cooling market. Because I don't think we can do that domestically. And I'm not so sure Thermobant wants to be in the business of running facilities overseas in that market. I've seen others do it unprofitably. I'm not so sure we want to follow them.
Understood. Thank you.
Awesome.
I have a super quick question, just related to performance. I was wondering how much of a no-brainer would it be for customers to switch over to this technology versus what they're using today?
I think that's a good question. It is a pretty clear no-brainer, and that's one of the value prop slides I was going to go through, right, on that, but we just don't have time to do it. The weight and temperature rise benefits that we offer are 2 to 8x better than alternative technologies. If weight isn't an issue, then sometimes you can use big heavy bricks of copper, right? Or but if to the extent that customers need to get heat out of their critical devices without adding too much size or weight, it is kind of I think our customers would verify it's a no-brainer. It's a cost and time to develop the new hardware question.
Yeah, and I'm sorry to interject, but as a past potential customer in Sierra Nevada, actually currently works with Thermobant, I can attest to what Joe just said.
Oh, thank you, John.
Okay, awesome. Thank you so much, Joe Boswell from Thermovent. We're wrapping up this session, but we're going to wrap it up is with a little bit of a roundtable. So thank you, Joe, for joining us.
Great, thank you.
No problem. So we're going to start with a question. It's a real merit for us to have an opportunity to talk to investors, corporations, and on this, the no government on this panel. So I think also the interesting perspective, which we'll gain later. When you are evaluating a company and a company explains to you their go-to-market plan, how detailed of a plan are you looking for? That's the first part of the question. And when do you feel calm and say, hey, this is a company we can trust? And then the last part, which is maybe nullifies the question altogether, how important is a go-to-market plan to you? So let's go around the horn. Nilesh, let's start with you.
Yeah, I mean, I sort of don't do a lot of pre-seed, seed type of investments where commercialization is, still farther away. So it's very important for me. What I look for is not, depth of the plan per se, but I want to get some proprietary insights into why that go-to-market channel or why the distribution that the founder or the CEO is seeking makes sense or doesn't make sense. Where is that the intimate knowledge of the market coming from? Usually I kind of find holes in that plan because it's a grand plan, but they don't know how to, when I say execute, how to get to the people that might help distribution, etc. So I'm looking for that, those insights rather than having a grand, scheme of plan. Yeah.
Awesome. John, how about you?
Yeah, so when we look at this, I would differ in I guess our approach. We actually do look for detailed planning, and that typically is how we assess the founder's domain knowledge. So that's what we really want to understand is, does this person have a unique insight, and is the go-to-market plan supported by a detailed analysis, that has, I guess a not novel insight or hard data that might be hard to come by, that establishes that plan as credible.
Awesome, cool. What about you, Cassandra? So I just want to follow investor, corporate, going back to investor. Go ahead, Cassandra.
Sorry. I probably fall somewhere a little bit in between the two, but something really important that both just mentioned was intimate understanding of the target market. I think that's also hugely important for us because often the companies we're looking at, if we're investing super early stage to a hard tech or deep tech company, they of course won't have a bunch of traction and revenue numbers, to show for. So it's really just, the technology itself might be absolutely brilliant, spun out of 15, 20 years of PhD research. But at the end of the day, if they're trying to cram it into a market that they don't, as the other two said, understand yet fully, or have proof that the customers actually want it. So whether it's detailed or not for us early on, it's understanding, are they actually working backwards from a problem? If we go and talk to existing pilots or even potential customers, would that same need for the product or service resonate with them already?
So to recap, it's more important for you to see an understanding of the market than the way to the market.
No, I'd say it's both. It's still very important to understand the way to the market as well, proving that they're actually solving a problem, basically.
Awesome, thank you. Lydia, what about you?
Sure. Yeah. So again, wanted to start with kind of the rounds I usually look at, which is series A, B, and C is our sweet spot. So usually there's already some initial revenue, and we can see, how the go-to-market, whether it's panning out as planned. I would personally look for what I call like product or channel product fit. So are you selling the product in the right channel? And it could be direct, it could be through, some channel partners, it could be through the distribution network. There's all kinds of types of sales or channel sales you can do. but figuring out like, have you picked the right channel for your specific product? And in some cases, it could be multiple channels that work, but also I want to see founders who are iterating and they're trying out, like maybe they started direct, and that's usually, everyone typically starts, with a direct customer relationship where you can, understand your customer, have that direct integration. And then as the product matures, you can start leveraging the channels and have resellers, have distributors, and folks who are the advocates of your product. So down the road, like B and C rounds, usually we tend to see a bit more like channel and a combination of channel and direct.
Awesome. If you see a mature company or like a B or C round that is still focused on a direct approach to the market, are you worried?
No, if it's, again, channel product fit, right? If they found the direct channel works really good for them and they're able to, whether it's, let's say, enterprise sales, it's SMB, they've nailed down like a rinse and repeat model. That's really what we want to see. Like, is it rinse and repeat, or is it like, and then also you can see that very clearly at the B and C rounds, because you can see the sales cycle over time, and has that sales cycle improved? And typically if the sales cycle is becoming shorter, that means you're starting to nail down the rinse and repeat motion, and it's a much more kind of predictable business then.
Awesome. Very cool. Miranda.
Hello.
Hi, what do you think? Go to market, how important it is to you, and how do you look at it?
Well, it totally depends on what area we're looking at. For those not aware of ZF, ZF is a tier 1 global automotive supplier of systems, several different types of systems. We're talking commercial, industrial, and pass car vehicles, among other types of vehicles, marine, aero, etc. And when we're talking go to market, and when we're looking at new types of companies, new automotive companies and emerging technology solutions that could be incorporated into automotive that maybe previously weren't, we're really looking at the area of startups who are ready for commercialization. So I'm sorry if I missed the point of what area that you were discussing previously, but I wasn't exactly 100% in.
You're closing in on how you view the topic, which is, how do you go to market when you're looking at a company? Yeah. I guess in the commercialization, it could be more important at that stage, right?
Right. I guess this is a tough question for me, because so what I'm looking at, my area of expertise is looking at new startup developments and bringing them into ZF and working co-collaboratively. So what we do is completely different outside of the regular commercialization and go-to-market strategy for ZF. That's outside of my expertise. My expertise is looking at getting those new automotive customers related into ZF or working co-collaboratively with ZF. When we're looking at that, the type of go-to-market strategy can be completely different depending on the area of technology. So per se, talking about a wide area, this is a wide range topic, but let's just say, for example, advanced sensors. When we're looking at advanced sensor topics and trying to get them commercialized or co-collaboratively developed with ZF, we'd be first looking in a very short type of agile type of sprint phase prior to MVP, similar to a proof of concept for maybe 12 to 18 weeks to really ensure that the relationship is working well and that the technology is scalable to all areas within ZF, if not at least a couple different divisions and technology groups. And then we would be looking at the go-to-market strategy, which would then be taken over by the division side.
Oh, awesome. Very cool. Very cool.
Sorry for the runaround answer there. I wasn't 100% present.
But no, it's perfect. It says that you're looking, because it's a strategic approach for the organization. You're also looking at innovation probably more than you're looking to go to market, honestly, right?
Right. So we're in a wide area of different types of technology. So when we're talking about next gen mobility, the most important aspect, or one of the most important aspects, is really looking at a scalable solution. Is it only pass car? Is it only ride sharing? Or could we perhaps take this industrially or perhaps commercially, or vice versa?
Right. Awesome. Thank you very much for that. Last but not least, Doron. We got you on mute still.
Okay, here we go. This is good?
Yeah, good.
All right. We early stage investors, so we look at things a little bit differently. We do have, being in Michigan in the center of mobility, we have quite a bit of connection to all the mobility ecosystem with all the expertise we need. But as early stage investor, we're pretty much looking at companies that are business focused. So another way to say it, that the company actually have a driver behind it. As we say in early stage investing, if you take a great driver, put him in a lousy car, you get above average performance. And if you take a great driver, put him in a lousy car, you get below average performance. So want to make sure somebody driving the company and actually going to do that. You know, all the numbers and the projection, the planning, it's in our world, it's fiction at best because it's early stages. We just want to make sure that somebody wake up in the morning and get in front of the wheel and drive. And we can see tractions and results in different areas and different places, but you know, the go-to-market strategy and what the plan to go to market is not as critical as, you know, finding the entry point and make sure that somebody have a chisel and a hammer and he's going to find the opening.
Awesome, awesome. Thank you so much. So first of all, before I introduce the panelists for the next session, I want to invite all our panelists to stay on, be involved, ask questions if you'd like to. And if not, then have a great rest of your day. And thank you so much for joining us, and please be in touch. Our next session is focused on advanced materials. And staying on is John Reifenberg from Sierra Nevada Corporation. And joining us also are Shintaro Kano from Shimizu Corporation, Kyle Adkins from Full Cycle Climate Partners, Tina Tasakawa from GC International, Gerald Coe, Divergent Capital, Matthew Cohen from Pangea Ventures, and from the DTRA, Christopher Brazier. Pitching today are going to be 5 companies: Evoke Nano, ABM Nano, C2 Sense Incorporated, Molecular Rebar Design, and Flight Material Science Corporation. So without further ado, we're going to get started. First up is going to be Dan Cohen. So you've all, I'll let you share the slides, and we'll get started right away. Just a reminder for the panelists, please have your cameras on so the presenters feel and know they have an audience. And after a 5-minute pitch by Dan, we're going to be doing a 5-minute Q&A. Hi, Dan.
Hi, everybody hear me okay?
Hey, great.
Slides are up. Okay, thank you everyone. Good day, good evening for wherever you are in the world. Thanks for being here today. I'm Dan Cohen, the founder of Flight Material Sciences. So please proceed to the next slide. So industrial products that we depend on fail when their surfaces fail because of rust or fouling or ice. And in spite of spending billions on coatings and much more on services, the failure of coatings causes risk and damage and loss on a scale so vast it can barely be counted. So we're introducing a radical new treatment for industrial materials to protect themselves using clean lasers instead of toxic coatings. And we're using this technique to protect human life, reduce environmental damage, and improve the lifetime safety and performance of industrial products. Next slide, please. So this technology took more than 30 years to create, but we're going to show it to you in 30 seconds. On your left, you see the surface of stainless steel, and when it's magnified, you see that it's rough and it's random. And any temporary coating that you put on by any method eventually will delaminate. Eventually it'll peel or crack or somehow separate. And cleaning and reapplying these coatings takes a lot of critical equipment out of service and a lot of cost. So we use a patented laser technique using high-speed laser pulses to sculpt a new functional surface. And this functional surface, like the one on the right, copied from the lotus leaf, is the one that repels water. Go to the next slide, please. Oh, if you click again, you'll get the, there we go. This is what a piece of stainless steel looks like when it's been treated to become super hydrophobic. This steel has no coating on it, no chemical before or after, just a nanotexture. And the liquids don't just run off, but they bounce off the surface and they take with it any dust or debris. And if water doesn't stay on the surface, ice can't hold there and rust doesn't form there and bacteria can't grow there either. Next slide, please. So to put it as simply as possible, if liquid is rolling off the surface and escaping liquid takes dust and debris away, we call it self-protecting or self-cleaning. Ice also, there are ice-phobic surfaces to create where we reduce the ice adhesion strength or inhibit ice from forming, which is important for a lot of industries. And we can also make heat escape of the surface without any extra cooling or weight. Next slide, please. It's important to know why we're different from the coatings industry that we track very carefully, because we don't necessarily have to add any material to the surface, and we don't have to etch away or remove anything from the surface. We're also not necessarily adding anything to the material to change its bulk properties. So manufacturers get to use the materials that they trust, but we can go where any coatings can't. It's completely green and safe throughout its life cycle, and it can even be used to enhance current coatings and bonds. Next slide, please. Now this has been tested with a wide variety of materials, more than 20 metals, glass, ceramics, polymers. Any solid continuous material can be treated with this laser surface functionalization. And by tuning the laser, we can actually make textures that repel water or oil, or attract water or oil to the surface for separation. We can also make surfaces that kill pathogens of all kinds and reduce heat and friction from the surface, as we've mentioned. Go to the next slide, please. Now, Flight has collected our IP and capabilities from labs around the world, and our licenses help us to build new IP. But you would expect perhaps that these nanotextures are fragile, but we've seen some very encouraging results. The stronger the underlying material, the more durable the benefit. And in our mission to bring this science to commercial utility, we're ready to demonstrate these benefits for the material and conditions of our variety of customers around the world. Next slide, please. Now, when we show this to people, their imagination starts to take them to where the benefits can be applied. And we've got a large catalog of validated opportunities and 3 customer validation projects going on today and 12 more scheduled for the next year. Our team has more than 100 years of experience, but as the team grows, we add experts with a lot of deep experience in each one of these sectors. So we're generalists, but we also have experts working with us in oil and gas and aerospace and other sectors. With more than 150 clients expressing interest, our sales have far outstripped our capacity. Next slide, please. Now, we are actively involved in some current projects that are dual use for both commercial and defense, in aircraft, mostly for keeping ice off of aircraft, which is a big safety and performance issue, but also for making stronger protective gear and robotics, keeping rust off metals, so the oil and gas sector is extremely excited, but also keeping cameras and sensors clear for automotive and aerospace purposes, and making better solar glass, both for the energy sector and for the space sector. So each of these are billion-dollar coating spend sectors who are disappointed by the protection that comes from current offerings, and our clients are eager to explore the alternatives. Next slide, please. So to make sure that Flight's innovation has maximum utility, we're also integrating with new laser technologies that bring us directly to the factory floor or maintenance. But our business model is to make the custom equipment that delivers this technique right into the customer's manufacturing or maintenance environments for long-term license and royalty fees at very high margins. Next slide, please. So all of Flight's applications are about longer lasting self-protective surfaces in critical environments. And we see a world where ships sail without poisoning the oceans, and safe medical devices last a lifetime, and clean water flows through pipes to reach all of us. We want you to give us your worst problems and let us show you how Flight makes everyday materials extraordinary. Thank you.
Awesome. Thank you so much, Dan. Let's open up the floor for questions. Go ahead, Tina.
Hi there. Tina Tozakowong from GC Ventures America. We are the corporate ventures arm of PTT Global Chemicals. So our corporation sell coatings. So I think this is a very intriguing technologies that you can create a surface that doesn't need coatings to be applied and then can repel dust and be self-cleaning. So if I heard correctly, the business model is to sell the machines, right? And,
well, the sale of the machines is really, it's because the machines are custom designed for the manufacturing or maintenance environment, but the real money is in the long-term licensing for those machines. So the margin on those machines is trivial. It's not meant to be a barrier to acquisition. It's really about the long-term relationship. And as that relationship grows, we're also present when the customers design their next generation of products. So we get to be there in the long run.
I see. So the licensing models, when they use, that's the real revenue. I think that's a great model. So tell me a little bit about this laser. Can it treat only the flat surfaces, or is there any sort of the geometry or the size limitation where it can be applied?
So we can apply to curved surfaces as well. In fact, our very earliest projects were for a faucet company, and we had to do faucet geometries. We can easily position the fiber tip of the laser around objects or move the objects around the laser, whichever is more convenient. As far as capacity goes, we can do large surfaces continuously at about 1.5 meters squared per minute of treatment. And for smaller objects, we can do bursts of the laser technology. So we can do about 10 square centimeters, or sorry, 10 by 10 in about 1 second in bursts. So that's interesting for different kind of products.
Thank you. Is there any sort of rule of thumb, what kind of applications value that you would recommend doing this surface treatment if the, so that you can, in the long run, make it cheaper than applying coatings?
Well, the difference between us and the coatings is that the cost of the infrastructure will be higher up front. But once the infrastructure is in place, the application really just converts electricity to laser pulses to textures. So the per unit economics goes down over time substantially, and that's where we hope to find our best competitive economics. In some industries, we're seeing that the coatings perform really well, and they're very inexpensive to apply and reapply in the field. So these are the areas we stay away from, but they still leave behind a great number of large industries that are desperate for a different solution.
Thank you.
Any questions from the panelists? We have 1 or 2 questions in the chat I want to get to also. Go ahead, Kyle.
I'll ask it. Go ahead, Kyle.
Yes. So the one that I was wondering about was sort of with the laser itself. Is there proprietary tech in terms of the actual laser, or is it just in terms of what you're actually commanding the laser to do in terms of the etching and all that? Because I'm thinking about, like, in terms of extensibility to much larger scale manufacturing applications, are you able to use existing industrial laser technology, or are you having to kind of scale your own technology in order to meet kind of larger scale demand?
It's a good question. The technology was really, the signal that it was ready to commercialize or industrialize was based partly on the commoditization of the core laser technology. So you can buy some of these core lasers with a credit card from a number of suppliers, but the IP rests with how to actually apply it. And there is some custom equipment to be designed to make sure those applications work outside of the lab environment. So yes, we can buy some very commoditized core equipment and scale those up in terms of power, but the getting the job done relies on a certain amount of customization and some novel work. Have I answered your question?
Yeah, no, that's exactly it. I mean, especially when you look at a lot of use cases there, you're looking at very large scale manufacturing operations. So just trying to understand what's the assumption you have to make to be able to actually address those markets on a big scale.
We have one group looking at making a much more powerful laser with the beam split into 60 to 100 streams, and another that says, let's use the low power lasers and just have a bunch of them working in an array simultaneously. So depending on where it's going, for example, in the semiconductor area, the smaller lasers might be better, but for large areas in marine or aerospace, it might be better to have a more powerful laser. So whatever is necessary, that's what we'll do.
Go ahead, Matthew.
Thanks. My question is, can you apply this in just ambient conditions, regardless of temperatures and humidity and having oxygen present, or does it need to be in any type of vacuum chamber? So maybe certain substrates are a little bit different, but that's I was hoping you could expand on that a little bit.
When this technology was first experimented with at Harvard in the 80s, it needed to be in a vacuum chamber with a toxic gas present, and conditions were very restrictive. And again, one of the signals that it was ready for industrialization was the ability to use it in open air conditions. So it would be best if those conditions were somewhat clean, but it can be done at standard temperature and pressure in a special lab conditions. It's not a NASA laser. And that's why we're already working on some field use applications, like for the built environment. If we're going to do stuff for oil and gas or the water industry, we have to get out to the field.
Awesome. I forgot to ask for everybody to introduce themselves, but that's Matthew Cohen from GF Ventures, and that was also Kyle Adkins from Full Cycle Climate Partners. You have one last question from Han Ko, and then we're going to move on to the next presentation. Han, Han wrote the question in the chat, but I think he also wanted to ask him live. Han, can you connect?
Yeah, I'm here. Yep. Actually, I was just typing on the chat room. Sorry. I'd like to know more about your price points. We've seen different solutions. By the way, your product and solutions are great, and we've seen different coatings. I'm trying to find out the price points compared to other coatings, other solutions. Can you elaborate a little bit, please?
Again, the price point is really based on the cost of the infrastructure to put in place. So although it might cost somewhere between 250,000 and even as large as several million for a very large complex installation, once that installation is in place, it's just the cost of electricity to apply. So the unit economics are based on long-term reuse of the solution. And we know that there are some coatings in place that are sufficient and extremely low cost, and we know not to chase after some consumer applications. So we actually are partnered loosely with a couple of super hydrophobic coating companies, so that when somebody calls and asks about this for food packaging or other low-cost environments, we just refer them to the coating companies, and in return, they refer us back when they get some industrial challenge they know they can't reach.
Thank you.
Fantastic. Thank you so much, Dan Cohen from Flight Materials.
Thanks for having me.
Next up is Mary Smith presenting for C2 Sense.
Great.
Mary, you there?
Yeah, I'm here. Can you hear me okay?
Perfect.
Wonderful. Good afternoon and evening, everybody. Thank you so much to the organizers for inviting us here today. C2 Sense is an early stage tough tech company. We're spun out of the MIT chemistry department. And at our core, we develop and produce sensing solutions for a healthier and safer world. Now today, I'm going to be speaking primarily about our breakthrough sensing platform called AuthentiTags, for which I'm the product manager. So we can go on to that next slide, please. Now, counterfeiting is the largest criminal enterprise on earth. And the dramatic expansion in online retail we've seen in the last few years has created very complex supply chains that offer havens for counterfeiters and opportunities for product damage and loss. Now, AuthentiTags were designed to address these problems by providing both counterfeit detection and product quality information from the point of manufacturing to the customer. We can go on to that next slide. The enabling technology behind AuthentiTags is a combination of light reactive molecules, data analytics, and low-cost readers. The premise is a chemically luminescent tag is added to a product or packaging, then activated by light. It then emits this energy back in an altered form. Software that's installed in a standard imaging device like a smartphone or industrial camera, it detects and reads this emitted energy, which contains coded information that can be resolved in both the wavelength and time domains. So it's this digital handshake between that software and the chemistry that has turned the digital camera into a luminescence detector, which is a breakthrough in the way that a smartphone can interface with its environment. Now, the luminescent tag can also be designed to chemically react with environmental changes. So for example, the tag can actually be tuned to change its signature in the presence of oxygen or humidity or different temperatures. And I'm actually going to show a demo of this later. But we can move on to that next slide, please. Our target markets include industries that have shared problems with these complex supply chains, with counterfeiting, and also with user safety. So in food packaging and pharmaceuticals, for example, temperature sensing is really needed to protect the cold chain. In luxury brands and pharma, counterfeit prevention, tamper evidence, track and trace, they're all needed to protect the brand. And in all these cases that you see here, the ability to detect problems in the supply chain and provide secure authentication are new to the industry and highly desirable. So we can go on to the next slide here. Seeing is believing to me. I mean, PowerPoint's great, but demos are better. So we're going to do a quick demo. We can start this first one here. In these demos, we're using a prototype reader based on an iPhone 11. In this demo here, we have two leather samples. The first one has no authent tag added. You can see when we scan it, the result is no. And the second has an authent tag. And when you scan it, the result is yes, tag present. So this detection and reading of these luminescent signatures happens instantaneously. And something else I want to show here is that these tags appear functionally identical. Our video is skipping a bit, but there's no difference between the two leather samples, tagged and untagged. We can start that next video. So the tags can be invisible, and they can also be used on different types of surfaces. So I've shown the leather demo first. This second demo is the same premise, but it's on glass. So this first glass stopper has no tag added, and the second stopper has a tag added. Unfortunately, I think our demo is skipping a little bit too much here, but you can see, and I'm happy to share these videos with you later, you would see in this demo that you have that X mark on the first one and the check mark on the second. And there's that ultra secure authentication piece that I was talking about previously. We can move on to that next slide. Now in this demo, I'm going to show a chemically reactive tag. So in this case, we first scan our package, which is sealed, and the check mark means yes, that package is sealed. If we open up the package, in this case, it's a catastrophic loss of our package seal, and we scan the tag, at this point, the tag signature has changed. So there you have it. The seal is broken. This is a tamper evidence tag that I'm showing here. And again, this happens instantaneously. We can go ahead and move on to the next slide. So again, our ability to sense these changes in temperature and gases and exposure to the elements really sets us apart from other brand protection solutions. And even better, our tags are easy to integrate and they're sustainable because they can be printed, they can be stamped, sprayed, mixed directly into products, which I'm showing here. And our final slide next here, our go-to-market strategy. We work directly with B2B partners to commercialize our first products. Currently, we have major partnerships established in each of the packaging, luxury brands, and pharmaceutical industries. We're currently looking for more strategic partnerships, of course, where our product offering brings tangible value to our partners. And we're also looking for strategic investors. We're currently closing a debt round in preparation for a priced round early next year. So please contact me if you would like to learn more about working with C2 Sense or more than I can fit into 5 minutes here. Thank you again to organizers, and happy to take some questions.
Awesome. Thank you so much, Mary. Open up the floor for questions. Go ahead, Tina.
Mary, thanks for your presentation. I think I've seen the authentication companies over the years, and it becomes sort of hard for me to differentiate it between different technologies and things like that. Can you talk a little bit about this chemiluminescence method? Is the chemical used for the tag has sort of the shelf life that, you know, once the manufacturer applies it, then it's going to last for a certain period of time. How long have you been testing that tags so far?
Great, thank you. Yeah, great questions. So a lot of authentication solutions on the marketplace and a lot of solutions for digitally connecting products. But there are very few solutions that offer both. And then when you add in that sensing piece, being able to tie in tamper evidence, being able to tie in temperature changes, what you're left with is really an IoT ink. You're left with a product that is incredibly dynamic, incredibly different in the marketplace, and just adds a lot more info to a single tag than just a QR code could have, for example. But your question about the additives, what the actual chemiluminescent materials we're adding. You know, we tune their lifetimes based on the needs of customers. So in one case, there's a market requirement from the luxury brands industry that because these are heritage pieces, that some of these tags last 20 years plus. And that's something we can absolutely do with our customers. And then in some cases, this is something that would be going onto a piece of food packaging, something that would probably be discarded and where you wouldn't want that tag to persist after a certain lifetime. And so we also are very happy to work with that too. And final thought, in some cases, you actually want the tag to end after a certain period of time. If you wanted to do something like shelf life, you wanted to say, look, after 2 years, this product is no longer good. That would be a tag we might want to tune to just destruct itself in a couple of years or fade away in a couple of years.
Thank you.
Awesome. Any last questions for Mary?
Maybe in a similar vein, what about the temperature stability of these tags? So depending on the market application you're looking to do, you might need to withstand, a few hundred degrees Celsius or similar. So if these are organic molecules, it might not be super well suited. So how does that work?
I can see my colleague Jason smiling. We've extruded these tags at high temperatures. That's one of the ways that we incorporate the tags directly into our materials. So in terms of temperature stability, we're not worried. Certainly the temperature sensitive tags, the ones that are reacting to temperature, that are telling the user something about temperature, they interact with temperature in a certain way, but in terms of their readability or their lifetime, that they're not going to be falling apart.
Thank you so much. That was Mary Smith from C2 Sense. Thanks, Mary.
Thanks, everybody.
Next up is Kurt Swager, CEO from Molecular Rebar Design. Kurt, you there? Let's make sure Kurt's on the line. I'm not seeing Kurt, so we'll skip him. We'll go to the next one. Up next, Julia from ABM Nano, Julia Chen, President and CEO.
Hi, hello everyone. So the slides is, do you have my slides, Yuval? Josh?
Yeah, Yuval, he's about to put it on. There it is.
Perfect, thank you. Next slide. All righty. Hello, everyone. I'm Julia Chen from ABM Nano. We are a manufacturing company here in Houston, Texas, providing high performance materials. I think we may want to zoom in a little bit, zoom out a little bit. Yeah, perfect. Thank you. So we are a high performance materials manufacturer from Houston, Texas. We have with our patented nanotechnology. Today, I want to talk to you about our current focus, one of our current focus, which is the solid state battery for the electric vehicles. Based on the market analysis in 2020 for the solid state battery, there's about $62 million value for the market, and it's going to grow dramatically in the next few years. Some of the analysis you can find are billions of dollars, and they're evaluated. So it's going to grow. For the next page, please. We're going to talk about, there's obvious reasons why we wanted to have the solid state batteries. And it's going to be the next generation, for the electric vehicles. Because of the flammable electrolytes in EVs poses severe safety concerns of catching fire and explosion. And we have cars destroyed, people were killed from the fire, and we want to stop that. We will develop this non-flammable solid electrolyte. And it's for the solid state battery, and the battery is safe and fast charging, and for the long mileage, and which gives you, eventually, it's going to give you the days of, battery that stay, you don't have to recharge again. And that's our goal. But currently, the market, if you can find any solid state battery supplier, it's still, there's some issues that they're challenging, and they cannot reach the solution for a reliable and scalable technology. Next page, please. So the good news is ABM Nano, we have developed this nanotechnology that gives you the solution. We wanted to replace the flammable liquid electrolyte by the solid electrolyte. And you see that the key problem is that solid electrolytes are centered from ceramic powder. And by the way, we are expert at powder because we have manufacturing powder and its advanced materials in the past 15 years. And we sold our business, one of our business in Montreal in 2014. And back then we've already delivered tons of powder. So we're the expert of powder, especially ceramic powder with our nanotechnology right now. So centered ceramic powder to high density electrolyte using lower temperature and less time has been a huge challenge. Now that ABM Nano can offer the nano-sized lithium solid electrolytes. The difference is that the liquid electrolytes that we can offer the solid electrolyte that has high efficient volume production with low cost, and it's going to give you the high ionic conductivity, high energy density, and the next thing is most importantly, dendrite free, which gives the safety. There's no explosion ever again. Next page, please. To compare the difference, on the left, you can see the current supplier. They are supplying the smallest particles they can offer is 5 to 7 micron size, which is going to be a low energy density and causes the dendrite issues, which result in the explosion. To the right, you can see ABM Nano. What we can offer is 50 nanoparticle size, and it's 100 times smaller. It's going to give you high energy density. We've already produced this product and patented. It's LZO powder. So it's going to be 100 times smaller, and we have fast, efficient processing capability for volume production. And you wanted to compare, basically, you're trying to burn the wood log, and versus you wanted to burn the sawdust, which is very easy, and it's going to be at least 20 times energy saving for the sintering process. And it's going to be thin film manufacturing, of course. Next page, please. Next, we wanted to show you, this is the competition. The current market, we have QuantumScape and Solid Power. These are the two companies who are already in stock market and raises billions of dollars for develop the solid state battery. But they still are facing lots of the technical issues. We believe ABM Nano would be able to partner with them if they're interested, and we can solve the problem, the fundamental problem for their, and they're trying to make the thin film and all different kind of technical problems they wanted to solve, and ABM would be able to working with them. For the next page, please. Now, here's the endorsement from this is advisor from ABM, and Dr. Steve Harris is professor from Berkeley Lab. He's commented that ABM Nano is the only technology that is going to help reduce the energy cost of a solid electrolyte, which is going to be commercially viable. And Professor Doherty from UIC commented this is going to be a major contribution. We're going to continue working with Berkeley Lab and Penn State and achieve the goal for the solid electrolyte. In the middle, you would see a 15 nanometer powder that's produced by ABM Nano. Next page, please.
30-second warning.
Yes, thank you, Victor. So here's the result from the experiment from Berkeley Lab and Penn State and UIC. All of their feedback are very promising, and it's showing that ABM is the only supplier offering the small nanoparticles of this powder. And Penn State, they wanted to continue working with us because this is the highest energy density they've ever seen. And UIC would show that very impressive dispersion from their experiment. Next page, please. So other than that, we are manufacturing all different kinds of powder with our nanotechnology. We have a broad base. We have the high entropy anion powder for coating for Air Force, and we have thermoelectric powder, high purity silicon powder, all different kind of materials for different applications. So basically, ABM Nano is the expert team specialized in custom manufacturing high performance nanopowder. And we have lots of experience in the past 15 years. Next page, please. So here's what we're looking for. We're looking for $3 million, and we wanted to continue the research with Berkeley Lab and Penn State, developing the prototype. We wanted to achieve that goal faster. And the next step would be the commercialization for the product of solid electrolyte and solid state battery. Hopefully we can partnership with those companies, which I showed above. Next page, please. And, in the next 5 years, if everything's going well, and we're going to have the IPO in place, having the investor on board with us. We're looking forward to working with anyone who's interested in solid state battery. Thank you very much.
Thank you so much, Julia. Questions from the panel? Go ahead, John.
Yeah, I agree with your statement that dendrites are a problem in solid state batteries. Do you have any data that actually shows that you've solved that problem? Because if you have, that's a really big deal. And that, those are some of the lingering challenges that QuantumScape and others are facing.
Absolutely. I understand that is definitely the key issue that we're trying to solve the problem. That basically it's the whole world are trying to solve that problem. So that's why ABM is able to, using this nanotechnology, processing this powder, which nobody else in this world would be able to produce this nano-sized powder compared to the current supplier that is the 5 to 7 micron. And what we have is 15 nanometer. I will tell you that's what we have already achieved, 15 nanometer size, which gives you, imagining that is the highest energy density you can ever achieve. And with the density, of course, the dendrite would not be an issue.
But you sinter the powder, so the resultant material will not be 50 nanometers, right?
Right. Well, with the sintering, that is why we work with Berkeley Lab and Penn State. We've already achieved above 93% of conductivity, and we have some pretty good science that shows that we have very good ionic conductivity. That's why the whole team is very excited.
Okay, thank you.
Thank you.
Go ahead, Tina.
I think maybe Han raised his hands first.
Oh, could be. I don't see him on camera, so it is.
Okay.
Oh, okay. Well, I can go first. Okay, it's going to be my quick. A great solution, by the way. Thank you.
Thank you.
Just quick, yeah. So quick question here. So your solution is how is different from? We've seen another group working on something similar solutions. Of course, many groups are doing that, but one group, I think they're from Harvard University. They're using the multi-layer design to solve this problem. How your solution is different from theirs? I'm just trying to understand a little bit more technology side of it. Thanks.
Thank you for the question. I think I read a little bit about multi-layer. I cannot really answer on behalf of them. I mean, I don't want to undermine their capability or their solution, but from what I understand, we have talked to a few professors, and the problem is that it's always stay on paper, and it's never achieved the real goal in reality. And for ABM, we've already achieved that powder in 15 nanometer, which nobody else has ever made that size. And it's in high performance. That is a huge difference. And we're trying to really help the world to achieve the goal, because we understand a lot of technical problem is because that there's no one else can make that kind of size powder with the high performance result. And the nanotechnology with ABM, patented nanotechnology, would be able to help them. And that's why I was at the Ceramic Expo in Cleveland, Ohio, showing everyone of our high entropy powder and the sodium-based powder, the battery powder. Hopefully, more and more people understand we can help them.
Awesome. Go ahead, Tina.
Julia, so help me a little bit on your IP. So my understanding is that solid state batteries, a lot has to do with chemistry as well. So is your IP covering just the method to reduce the particle size, or does it also, cover the composition of the matters? Because if it just covering just the particle size formation, then it means that you will always have to work with other companies, right, in order to commercialize the solid state electrolytes. So help me a little bit here.
Thank you, Tina. That's a very good question. I get that question a lot. And basically what we can do is a process of mechanical alloying. So it's not just about reduce the powder. Reduce the powder significantly is certainly one of our advantage. And that's also very important. Imagining nanotechnology is basically giving you the option of having everything smaller and lighter and thinner. And at the same time, it gives you the high performance. I keep talking about that because mechanical alloying is basically giving you different materials combined together and recreate a new material for you. So, so it's not just about A plus B plus C material result. It's a new material that we are creating.
And for the solid states application, is your IP covering the composition of the matter?
Yes, we cover the composition as well.
Thank you.
Awesome. I think we have time for just one last question. Yoav, you want to take that?
Yes. A question about your business model. Are you planning to be manufacturing batteries or just providing the technology for battery manufacturers? Because you know, if you're going after manufacturing batteries, that's hundreds of millions of dollars in investment in building capacity, etc.
Yes, thank you. That was a very good question. Also, we have thought about this. We have a lot of discussion. The thing is that there's a lot of patents involved in this technology. So battery, like company like Samsung and many other companies in South Korea, in Japan, in China, they have lots of patents involved, and in US as well. So we wanted to really partnership with those companies to really produce a solid electrolyte. We wanted to be the one who's supplying the solid electrolyte, which is the key part of the solid state battery, because right now people are providing the liquid battery, the solid electrolytes, which is the key issue of the fire. So we wanted to solve that problem. And for the rest of it, I mean, we can make cathode as well. Basically, the whole part of the powder of the solid state battery is made of powder. And we have that capability producing a nano-sized powder. So the next step would be the sintering, and it would be the thin film, and goes to the battery.
Thank you.
Thank you.
Thank you so much, Julia, from ABM Nano.
Thank you.
Pleasure. So next up, we're going back to black diamond structures / molecular rebar design. And I think we have Kirk Speck online. You there?
I am.
How you doing?
Well, first I have to apologize. I had it on my calendar for an hour later Central Time rather than Eastern Time. But thank you for inviting me. We'd like to talk a little bit about what we do with molecular rebar, and we enable quite a few things which we'll discuss. Black Diamond Structures is the entity marketing and selling. It's owned by Molecular Rebar Design. I'm the CEO of both. It's based on technology derived by my partner and I. So it's actually, this material is out being sold for lead batteries. It's in the various development tracks of a variety of customers in batteries. It's the same technology we use for rubber and tires. What we can do with tires is reduce the weight, reduce the hysteresis, improve fuel economy, and make them tougher, stronger. In biotech, we can transfer stuff into cells. In coatings, we can make corrosion coatings last 2 or 3 times longer. 3D printing, it improves the dimensional stability and impact properties. So it's got this technology's got a broad range of uses. And the most advanced, I'd say commercially, is what we'll talk about, which is for energy storage. We can go to the next one. So one of our technology guys came up with, here are things we're trying to fix in the current lithium batteries. Our goal is to have faster charging, longer lasting, safer, and lower cost batteries. The key challenge is the charge rate's too slow. Right now, it takes taking an hour to charge a battery is not so acceptable. They're large and heavy. That's why the tires are wearing out quite a bit earlier, and they're pretty expensive, as you all know. So what we do is to help with this is on the anode side, if you add silica to the graphite, we all know the energy density goes up, but the lifetime goes down. Addition of a small amount of our material helps preserve the silica crystals, and we can get well over 1,000 cycles, or at least our customers can, and therefore that's now makes it, enables the technology. And we're talking 15, 20, 25% silica in the anode, which then lets you someplace around 30 to 40% better energy density. On the other side of the battery and the cathode side, what we do is we replace existing carbon nanotube bundles with our material and dramatically improve the charge at high capacity rate. And we're looking at 4 or 5 times faster depending on the algorithms. I'd love to say we figured this out, but actually our customers did. We just scrambled to get ahead of them a little bit. And when you basically can take and charge faster, and then if you have much higher energy density, your batteries can get smaller, or you can go a longer distance and you can reduce cost. And then what we have is solutions, different kinds of products for each of these applications. Some are in water, some are in solvent. Our third area that we'll work on later is a new electrolyte, but this is keeping us busy. These products are all have been tested. We've worked up with, we're at 24 customers. We're focused down to about 8 or 9 because that's about what we can handle. Next slide. So this is what our customers achieve. You talk all the theory you want, but it counts as what your customers see. And they see faster charging, faster discharging, improved cycle life, which was a bit of a surprise to us. And this is cycles of the whole battery. And what we're really doing is replacing the current cathode additives with very small amounts of our material. We are at the nano size, and I'll show you a picture in about a minute. And the bundles that they use today are at the micron size. In the anodes, cycle life, this is improved versus other materials, but we see, and we also see improved mechanical properties, which helps in the processing. So we've made a heck of an impact on our customers. And as I said, in lead batteries, we'll sell $3-4 million worth this year and double that next year. For lithium, we've got one customer all the way through. They're starting to market. The rest of them are going in the A, the B, the C, various development cycles for particularly electric vehicles. So I can't help myself. I have to show what the technology actually is. Next slide. So what we do is we buy bundles from people in China, Korea, and Russia. Unfortunately, there's no real supply in US. We detangle them into the individual tubes, and those are what let us really make the magic. We have about 120 patents protecting this. They're mostly composition patents related to the individual tubes and the coatings on the tubes. Next slide. So as I said, we've got, and then basically we've organized that into 4 layers. We've got a lot of redundancy, and they're scattered all over the world. So this is not so much how the tubes are made, it's their use patents. And the next one. So what do we need? Well, we're always interested in investment. We need to add more capacity. we need to add development capacity, and we need to add licensing capacity with all those patents. Our investment banker is Hamilton Clark, and there's a variety of options for this area. So thanks for the time to let me describe a little bit about what we're about.
Awesome. Thank you so much, Kurt. Opening up the floor for questions.
I can ask a question here. So what is your Envision business model? Is it to sell formulations, or to license the technology, or to be kind of more of a full solution provider, or something else entirely? And maybe it depends a bit on an industry basis.
That's a good question. Right now, we're supplying a component for the various, I'll call them binders, but supplier. We do not intend to try to do the whole market. So it'll be a mixture of selling product and licensing.
Awesome. Any other questions for Kurt? We have time for about one last question if there's. Okay. Thank you so much. This is Kurt Schwager from Molecular Rebar Design and also Black Diamond Structures. Thanks for joining us.
Thank you.
All right, up next and last for the advanced materials session is Evoke Nano. And we're joined by David Nielsen, the Vice President of Evoke Nano.
Thanks, Josh. We're very excited to talk with you all today. As Josh said, my name is Dave Nielsen, and I work with incredible scientists to find ways of using our platform to make existing technologies better. And one of those areas is in battery and energy storage, and we're thrilled to share with you our technologies and specifically how we improve lead acid and lithium battery performance. Next slide, please. Getting right to the point, in the battery marketplace, we help rechargeable energy systems charge faster, and we help them hold more charge and last longer and operate more safely using our EVQ-GA material. Next slide. There are massive challenges to overcome in existing battery technology, as well as in developing future battery technology. And one of those issues is that demand for energy storage is increasing logarithmically, and these batteries need to charge faster and last longer and have smaller footprints. Next slide. In the next 20 years, the demand for energy and energy storage is going to increase substantially. The Department of Energy predicts there will need to be 300 million high-powered rapid charging stations to meet demand. Next slide. Lead acid battery demand is expected to require an additional 115 gigawatt hours, which is the equivalent of 1.2 billion 100-watt light bulbs. And for lithium, it's even more. It's expected to require an additional 2,700 gigawatt hours, which ends up being the equivalent of 27.5 billion 100-watt light bulbs. Next slide. So we've engineered a cost-effective solution that will help batteries today and with the development of rechargeable energy storage systems in the future. We've engineered a gold allotrope, which is science speak for a different form of gold. It's like comparing graphite to diamonds. One type of carbon is for pencils and the other is for engagement rings. So our gold nanoparticles are engineered specifically for energy storage systems. They're spherically shaped, custom sized, they don't aggregate, they don't follow a solution, which is to say they'll stay perfectly mixed in any solution, which is incredibly important when dealing with battery electrolyte solutions. And these properties may sound interesting, but if the specs didn't grab you, what may grab your attention is that this combination of technology is critical when it comes to improving battery performance. Next slide. It sounds like many of you already know this, but one of the biggest challenges that exists when building batteries that charge faster and last longer is that they're prone to forming dendrites. And if batteries have a cancer, you know this is it. They're responsible for poor performance, batteries shorting out, and when you've heard of batteries catching fire, this is why. And Dr. Chu from Stanford recently stated in the US National Academy of Sciences that building a fast charging battery that can suppress dendrites is a holy grail problem. Next slide. Incorporating our EVQ-GA into the electrolytes of batteries suppresses and impedes dendritic crystal formation. We've used scanning transmission electron microscopy, which gives us a clear picture of when using EVQ-GA. The dendrites are significantly smaller. These images show that we had a 75 to 90% reduction compared to those in normal batteries. Next slide. We performed testing in laboratories under controlled conditions, and it showed that our batteries using EVQGA charged faster, had more amperage, lasted longer, they were safer, and extended the overall lifetime of the battery. So we decided to take our lab data and did some field work testing. Next slide. When we tested our lead acid batteries, we saw a greater than 20% increase in amperage, a 50% reduction in charge time. We also saw a 90% decrease in dendrite formation. And the data indicated that with existing battery technology today, we'd be able to decrease the battery footprint by 18% and get the same energy storage performance with improved recharging times. We also would see a 30% increase in battery life. And we're currently performing field tests with our lithium systems, and we expect similar, if not better, results. Next slide. We know that we're different from other nanotechnology companies, both in our technology as well as how we're positioned. We have 22 granted patents and 23 pending. Of our patents, 9 have been granted for battery and 10 additional are patent pending, again, specifically for battery. We're engaged with award-winning academic scientists, electrochemistry, and have access to one of the few National Science Foundation's material research science and engineering labs. And it allows us to test and validate our claims. We received recognition for our technology with an invitation to present at the recent Lead Acid Battery Conference. And as a side note, we have been recognized for our work in textile applications and have been awarded grants for our ongoing work in developing pharmaceutical and biotechnology devices. Next slide. We are interested in working with commercial entities who would like to be in a pilot using our development kits. This is where you can take our material and assess its performance within your company's manufacturing environment. And this is essentially a qualified test run. We're also looking to partner with government agencies who are looking for ways to improve energy infrastructure as well as decrease the overall costs associated with development of rechargeable energy systems. And then for anyone who wants to join us on our journey, we're also seeking strategic investors. And the contact information of our CEO and VP of sales is also at the bottom of this slide. Next slide. We feel we have an exceptional team. Bill Niedermeyer is the founder of technology. He's a world-class expert in high energy physics. Dr. Kennan heads up our science team. I'm a senior scientific advisor for Evoke Nano. Brent Lindy heads up our sales, and Brian Bertha is our CEO. And as a side note, we're currently at the Battery Show Conference in Michigan. For any who are there and would like to meet with us personally, we'd love to be able to meet and talk with you a bit more. Next slide. We are excited to work with you and together accelerate the future of energy storage systems. We welcome any questions. Thanks.
Thank you, David. Fantastic. Go ahead, Kyle.
So I think kind of a similar question to some of the other panelists is trying to understand where you expect to fit with existing battery manufacturers. Are you co-opting them? Is this a technology that can be adopted by them and an improvement to their process that you then license? Or how are you expecting the business model to work?
Thank you for the question. Really what we want to do is we want to be able to test out the technology with commercial partners and then identify what's going to be the best solution for them. I mean, currently we're set up to be able to source all the material and we're able to scale it to the level that would be needed in order to be able to provide them the material to incorporate into their manufacturing processes. But we're certainly open to licensing the technology domestically.
Maybe I'll ask the next question. Currently, where do you incorporate this gold electrode particle? Is it in the electrodes or electrolyte? And I think the presentation mentioned that the battery can be 18% smaller. With the current loadings, do you have sort of an estimate the cost of this additive? How much incremental cost would that be for the whole lithium-ion battery system?
Yeah, thank you for the question. So right now, the material is incorporated in both the electrolyte and in the paste that is applied to the batteries. And it's in the electrolyte that will allow for the nanoparticles to act as seeds, and they allow for the electroactive species to be a bit smaller, but also more numerous. And that's what is able to show that it increases the amperage. And then for the charge-discharge cycles, it can be much more effective. And that's shown by adding it to the electrolyte and to the paste. We expect to be cost competitive with regards to what it will mean for energy storage manufacturers, batteries, and such. And so, when we're working with companies who are interested in incorporating the technology, we know that we can manufacture in a way that will enable us to be cost competitive. Does that answer your question?
Sort of. I was looking for the quantitative number, I guess, like, because this is gold particle, right? So you save 18% of the size, but that's because it's gold. Does it add you back, the 18% of the cost of the component cost?
I can understand that, and with gold being as expensive as it is today, the size of the material and the volume of the material, we know that we'd be able to be incorporated into a manufacturing process that would not significantly add to the cost structure needed for manufacturing the batteries, and ultimately being able to sell them business to business to consumers down the line.
Great. Any last questions? John, did you have a question?
I did, but she just asked it, so.
Okay, perfect. I'll finish with one question. David, any additional markets other than lithium and lead battery?
Well, we certainly have applications in anti-corrosion. The nature of gold is showing that that impact on being able to avoid corrosion in battery environments is critical, and that's an area that we're definitely looking into, particularly in like harsh environments where corrosion is common, either through environmental environments, or with regards to like repeated force systems, machinery and such. So those are some of the areas that we're also pursuing. And as we mentioned before, we're working in biotechnology and pharmaceuticals for being able to create antimicrobial treatments, therapeutics, and products.
Awesome. Thank you so much, David.
Thank you.
That was David presenting for Evoke Nano. And with this, we conclude our advanced materials session. Thank you, everybody who helped out here. I just thank the panelists for the session. We had John Reifenberg from Sierra Nevada Corporation, Shutara Kano from Shimizu Corporation, Kyle Atkins from Full Cycle Climate Partners, from GC International, Tim Tasakawan, from Divergent Capital, Gerald Coe, from Pangea Ventures, Matthew Cohen, and from the DTRA, Christopher Brazier. So thank you, everybody. And for the companies that pitched, Evoke Nano, C2 Sense Incorporated, AVM Nano, Molecular Rebar Design, and Flight Materials Sciences. So thank you, everybody. We're moving on to our final session. I just want to extend an invite for the panelists who would like to stay on and continue to ask great questions. And the same with the companies if they want to continue on here the different pitches. So without further ado, we're moving on to our last session. I think I can't actually share the screen, or maybe I can. There we go. I got it. So we're joined by Hyuk-Jin Soo, Dr. Hyuk-Jin Soo, from Sky River Ventures, from Mighty Capital, David Anderson, Mobilon Ventures, we have Anna Lazarovici, or Exting, from the United States Air Force, Nathaniel Shaflin, from Prime Movers Lab, Alessandro Levy, from Next Year Ventures, Yoav Weiser, from Sierra Nevada Corporation, continue with us is John Reifenberg, from the ZF Group, the ZF Group, sorry, Miranda Watt is joining us. She was also on our first session. Kyle Atkins is continuing with us from Full Cycle Climate Partners. From Thales Cloud Security, Solomon Cates. From Applied Ventures, Rajesh Ramanujam, and Christopher Brazier is continuing with us from the DTRA. Companies presenting in this section, we have 4 of them, and they are, hold on a second, let me get my screen going. Inerti Incorporated, Turing Micro, Simbec Corporation, and Tardin Silicon System. So without further ado, we can get started right on with that session. So welcome everybody to the Semiconductors and Electronics session, third and final session. First up is Greg Paul, co-founder and president of Turing Micro.
Hi, can you guys hear me okay?
Perfect.
Okay, great. Thanks for having us. Turing Micro is a new architecture, a new way to compute, and we've patented it. Next slide. We have a world-class team of guys from Western Digital, Bob Cotillar, the inventor, also main designer on the first processor of the Xbox, 26 microprocessor patents, and our CTO with 53 patents from Western Digital as well, George Bennett. Next slide. So there's a problem in microprocessing today. We've all heard of Moore's Law, and to speed it up, you have to hybrid a bunch of different processors together. Those are GPUs, FPGAs, CPUs, and ASICs. They all do one or two things really good, but they can't replace each other. And the problem is it's batch computing. They classically all can compute many things if put together, or if like a CPU, like in the computer I'm talking on, can compute all things, but it takes a long time to compute all things. And it's kind of like getting an omelet at your hotel and there's 20 people in line, but one guy cooking. So we're going the opposite direction in our architecture, and architecture is what's going to keep Moore's Law alive. I don't know if any of you watched the Tesla Dojo thing last week. That's what they have, new architecture. We're ahead of that game with people like Samba Nova. We're patented, but oversized centralized cores slow everything down. So next page. So we've invented a architecture, and that's the flowchart. That's how you compute. That sits on top of everything that happens at the foundry. For 50 years, it's been the foundry that's made compute faster as they shrink the node size down and make everything more dense. In our architecture, we can do several things, and we do it all in one clock cycle. A clock cycle is the fastest anything can happen. You can speed up the clock cycles, but it's the fastest step that anything can happen. So if something's at 2 gigahertz, that's 2 billion clock cycles a second. We do zillions of cores, many of them, instead of 2 or 4 big ones, and we do them for each piece of an algorithm. They're made out of flash memory. They can be made out of MRAM as well. So Nathaniel there with the Air Force, definitely like to show you more about that we've been showing NASA and some others. But we can dynamically reconfigure and change the path and the way it computes. It's not an FPGA, it's not a GPU, it's a new way to compute, and it's a cookie cutter. We can also change the power and voltage. So things like swap become very exciting with this architecture because we can slow it down or speed it up when needed. Next page, please. So we're patented. We are a chip and a compiler. The compiler has all the intelligence, that's software. It's a language translator, basically. And we get these things on the right here in blue that your FPGA, field programmable gate arrays, and GPUs cannot do, and sometimes ASICs, which can only do really one thing. Dynamic reconfigurability, we get 3D processing layers virtually, virtual fabric basically, out of 2D manufacturing. And we'll see a picture of that in the next slide in a minute. But by simplifying compute and data movement across the chip, we are able to do everything in a clock cycle and move across the layers of that chip that are stacked, kind of like a magical elevator. So if anything comes in the way, one clock cycle, we jump to another layer. We can be doing an entirely different type of compute on every layer. And again, this is not built in 3D, it's virtual. So we do a stacking technique. That's also allows it to do cybersecurity, because just like spread spectrum and frequency hopping, where the frequency is jumping around millions of times, we can jump around and jump around naturally, which will mask the signature and the randomization. So auto mapping and timing, which are all the collisions and all the difficulty of designing a processor or redesigning a processor in an FPGA, are gone. with this technology, and let alone these things we can do over the others. So your ROI, your faster turnaround, and again, that's because everything's done in one clock cycle, and it can jump in one clock cycle. So you don't have to do mapping. You don't have to do routing. It'll automatically do it for you. And again, patented. Next page, please. So here are layers of compute. Think of top right there, that paper thin checkerboard. If the checkerboard is paper thin and we stack it a bunch of times, it's very small. So that's how we jump around the squares through it and keep our density where we need it. But we can go X, Y, Z, and then on any layer we can go in any direction. In 7 different directions in one clock cycle and initiate. So we can initiate, it organizes the code, it compresses the code. We don't have the context switching. We're not going back and forth to memory. We carry it, we're data flow. Next page, please.
A 30-second warning.
Okay, SWAP, talking with Lockheed and NASA about obviously smaller, lightweight, and power. Next page, please. So also Nathaniel at the Air Force, we are phase 1 awarded. We're in phase 2. We had a MOU signed until 3 weeks ago. He is retiring, and this was with the this $900 million project with the DoD to be the network of tomorrow. But this is a comparison of us. We call it IRDA, Instant Reconfigurable Distributed Array across the bottom. But we touch all of compute from left to right, from the smallest IoT, drones, autonomous AI, 5G, streaming, video streaming, supercomputing, all the way up to wafer scale, wafer chip, just like Cerebrus, but better. We don't have to do so much hardware. We've got a better architecture and scalable, but we don't have to start there. We can start on the easy stuff. Also in robotics, we have real-time high performance because everything's done in one clock cycle. So everything can happen faster. That includes every type of thing like high frequency trading. Next page, please. So where are we going from left to right? Easiest stuff, robotics, high frequency trading, anywhere in FPGA and GPU are, and in a lot of cases ASICs, AI, VR, and then like I said, all the way over to the acceleration and supercomputing and wafer scale. Next page. So we're trying to raise 6 million to do a couple multi-project wafer runs and build the compiler. And finally, I think that's the last page, but one more, we're a licensing model, just like what's in your iPhone ARM. They license it to Apple. Apple then makes a technology upon that. And so we can be in any foundry. Currently, we're in simulation stage and ready to build out a simulation and FPGA. Again, looking for an MOU signer, we'll bring $750,000 with that through the SIBR and AFRL in the next 40 days. We have to find that signer. If any of you are part of the military and understand that with somebody in the Air Force. But working with a bunch of different groups, and especially out of Australia, I'm here in London right now because of that, and happy to take any questions.
Awesome. Thank you so much, Greg.
Thank you.
Let's open up the floor. Go ahead, Dave.
Hey, Greg. Nice to meet you.
Hi.
So first of all, thank you. I'm Anna from Mobilion Ventures. I would like to better understand in which sectors would you like to focus first, because as you said, you can go to many sectors and spread all over, and I'm trying to understand where do you want to start and what kind of investors are you looking for?
Well, easiest sectors to start, robotics, high frequency trading, video streaming, AR, VR, because less of the compiler has to be written. We can start with literally hand coding your algorithms to get into that. Type of investors, well, always strategics are the best. So there's many places across the board we can help, and we can go in any of those directions from start and do that a multiplicity of ways. We can work with any foundry. That's Global Foundry, ST Micro across the board, obviously trying to stay with a US friendly due to our grants and those kind of things and patents. And any node size, not locked. Anything in the foundries, we sit above. We can help compute across the board. We're a faster, easier, and better reconfigurable way to compute. And that is the answer going forward to Moore's Law.
Thank you, Greg.
Thank you.
Go ahead, Dave.
Hi, this is Dave Anderson. I'm a partner at Mighty Capital. It sounds almost too good to be true.
Good.
Do you have any benchmark data or simulated benchmark data that shows the benefit over some of the existing architectures?
Sure. So we have, I can take you through with our CTO a 60-page PowerPoint to show you how it works and why, and explain the patents, and also patents you can't read right now. We are creating, and that's part of what we want to do with this SIBR simulation that we have partially with Simulink. And then what you do is you when you build a chip, you make simulation and then you dump it into FPGA to show it as well, like a Xilinx FPGA, for example. So we have lots to show if you'd like to have a meeting or anybody like that.
Oh, my second question is, is it possible that this new architecture might actually introduce reliability problems to the coding?
No, it makes it much, much simpler. You code one line now because, for example, our compiler starts on top of everything MATLAB does as far as all the algorithms. You're not having to code the routing and the directions and the collisions anymore. A software guy can drop down, just have his algorithm. It's like if I was going to do a robotic finger, I don't have to worry about all the steps. We're massively horizontally parallel. And so the coding is much simpler.
Thank you.
Thank you.
Hi, this is Chuck Chen, Skyro Ventures. I had a question for you. I'm not sure if I quite understood what you're saying when you have this vertically stacked. Did you mean physically vertically stacked, like a 3D NAND, or are you talking about?
No, I mean virtually. We do stacking, but it's 2D manufacturing. So part of the patents are that we internally speed the clocks. So if you got an outside clock, let's say going at one time a second, and you got one going 4 times faster internally, you can get to any of these places much quicker without affecting the outside clock. So we have patents to do that, and we know why it works for a bunch of reasons from our past. And so,
does that require any additional, cache memory internally in order to do that? Because you're compiling at a faster rate?
We are data flow, so we're not doing context switching, going back and forth to memory nearly as much as anything else. But we are memory intensive. So we are a cookie cutter of flash memory, or if military and want to be rad hardened MRAM and those kind of things. We can be any type of flash memory, so S or D. But yeah, it's definitely memory intensive. But you get way more performance.
And when is your first tape out? When is your first tape out?
When is that? So we believe that would be within 9 months of certain funding we're trying to have right now. We're trying to do 2 tape outs in 18 months in the scale that we have. We're working with a group right now, the convertible note, and potentially an A and B round of 2 different groups.
Fantastic. I think that wraps up the session. Thank you so much, Greg, from Turing Micro.
Much appreciated.
Awesome. Just moving forward. Next company is Inerti. The pitching is Richard Merlick, CEO and founder.
Unmute. Hold on.
There, we got you, Richard. We hear you.
You got me?
Yeah, we just would love to see your face.
Oh, I'm trying to get that. Hold on. Okay, there we go. There we go.
Perfect.
Okay?
Yeah.
Perfect. Hello, everyone. My name is Richard Merlick. I'm CEO of Inerti. Our mission at Inerti is to design and deploy reliable clean energy solutions where they provide the most value. The next slide, please. To achieve climate change and reliability goals, we need clean energy assets where they provide the most value, and that's at the grid edge. But there are technical, physical, and financial challenges that make it prohibitive. really hard to connect. Both the building panels and the utility service capacity make solar storage and EV charging complicated and difficult to connect. There's space constraints on every commercial location. And finally, it's very costly. While battery costs have declined significantly over the last few years, the bulk of energy storage costs are in the non-battery cost component. Next slide, please. So just prior to founding Intertie, we built the largest integrated solar carport and charging facility in California, I think at the country at the time. And that gave us an experience and insight into how charging was going to impact the grid. We developed a battery boosted fast charger, which we refer to as an it's an EV charge pod. And not only does it provide, it had an integrated underground battery system with a charger on top. It manages site energy use and provides grid services. After we completed that prototype, California enacted temporary relief to demand charges, which was our main value proposition. And so we pivoted, and what we recognized is that what we had developed was really a productized microgrid with hardened storage, DC coupled charging and solar, and then an energy management system from which we could deploy and provide many services. Next slide, please. As a company, we're most interested in providing value-added services through our technology. And we've developed software along with the hardware of the productized intelligent microgrid, and we can transform really any building into an efficient, profitable, clean energy asset, lowering costs through peak shaving, load shifting, solar maximization, improving the reliability with backup power, and adding new revenues, demand response, submetering, and other services. Next slide, please. The market has a funny way of telling you what has value. And since we are in the marketplace, and I define our core technology as what has the most commercial value. And it's clearly the hardened, safe storage system that we've developed. We've got a patented underground storage system that provides the safest, lowest cost, and most versatile storage. You can see an illustration here, doesn't take up any space. It's in a parking spot. And there's a lot of technology that's embedded in that, both on the structural side of the vault, the battery, and then the systems that go along with it. The other main advantage is nature. It's located in an optimal temperature environment, so it obviates the need for HVAC. As you can see, it's very easy to install. Our first model was 8,000 pounds. Through technology, we're able to lower that down to 1,000 pounds. It's secure. We have a climate control system. And at the end of the day, if you see on the far right, you don't even know the storage is there. The other core technology is really a DC topology that enables us to couple a charger directly to a battery and couple solar directly to a battery. And that provides many advantages in the microgrid space. And then finally, we build a productized integrated microgrid. And by providing a turnkey storage, charging, and solar solution, either individually or combined, we increasingly are finding our customers want a one-stop shop, and we provide them a configurable, versatile energy service platform to make money. Next slide, please. Our real competitive advantage is through the technology, we can install storage almost anywhere, and it's intrinsically safe. And I alluded to earlier, by locating it underground, we maximize the operational efficiency. But the real key is when we consider energy storage, you have to look at the total cost of energy storage. As you can see, the battery is about 20% of the cost of a storage solution. By productizing the microgrid and being able to locate that battery anywhere, we can cut that non-battery cost by half. And although our battery is a little bit higher because it's enclosed in the underground vault, we cut the non-battery cost by half, and we have a competitive cost advantage vis-a-vis our competitors in the small and medium building commercial space. Next slide, please.
Hey, Richard,
Yes.
30-second warning.
Oh, shoot. Okay. Let's go to the next slide. This is a huge market that we're talking about. The addressable market's about $700 billion. That's just in the US alone. Our focus in California, it's a $200 billion market. And where we feel we have a competitive advantage, it's about a $30 billion market. Next slide, please. There's a, where you have a big market, you have lots of competitors. We see that our advantage in the small to medium building space gives us a competitive advantage, and we believe we have a first mover here. And so our focus is to execute this year on that and get enough scale out there. Next slide, please. Again, we started with an idea from a project. Our concept was completed out in 2017. We built prototypes for all of the microgrid components. We won the Shell Game Changer, recognized our fast charger competition. You'll see the final version of our prototype in 2019. We've deployed it. We have a microgrid installation, and we just raised the Series A. We have 7 microgrids in various forms of development stage and projects now. Next slide. Our team is, I, as a founder and CEO, I have the pretty extensive domain knowledge in the utility space. We combine software, commercial, and then net zero energy expertise as our leadership team. Next slide, please. And then finally, we're not looking for immediate equity capital, as we recently closed our Series A. We're using our Series A to commercialize a robust demand for our underground storage, but we're happy to have discussions with potential Series B and follow up with them. But one of our asks is we're looking for tax equity and debt partners, because project financing allows us to add a lot of leverage to our investor capital. One of the purposes today, we'd like to meet with industry and military stakeholders, as our technology has a broad application. We could expand that technology to be resilient in flood and fire zones. And we want to better understand what the pain points are of customers, particularly in the defense space, and sign MOUs. Our wish is being in the field and engagement with customers and installing. We have a comprehensive product roadmap to develop. We are seeking non-dilutive funding to advance some of these products, because we think innovation and continuing in that vein will continue to give us a competitive advantage. Thank you.
Thank you, Richard. Opening up the floor for questions. Go ahead, Kyle.
So Richard, you said that you've done 7 microgrid deployments to date. Were you doing that in partners with other kind of microgrid technologies, or how did those work, and how do you envision this going forward? Because batteries obviously are only, in your system, it sounds like it's only kind of one piece of the overall puzzle in order to actually deploy a full microgrid.
No, we build a DC coupled solar integration device. We have our own energy management system. We have our complete underground battery storage system. We have a DC coupled fast charger. So we provide all of the hardware components, some of which will have partnerships. So for instance, on the fast charging, Tritium is a partner of ours. We'll modify their technology so that it can become more grid friendly. And those are the partnerships that we have. But we do 100% of the work on our microgrid deployment, from site assessment to engineering and permitting to finally commissioning the microgrid as well.
Got it. Thank you. We should follow up offline on some things. I got some ideas.
Go ahead.
Yes. Are you selling this microgrid station? You're leasing them? What's the business model for the end customer?
So our business model is all of the above. So about 50% of our project, the end customer, like a Fortune 500 company, will buy the product, right? Where we are in the Bay Area, because space is a premium, very strong demand for our patented underground system. We can locate it anywhere on the property. So many of the real estate developers, particularly if they're doing a tenant improvement and have capital, they'll buy it. And then there's another fraction that will, and then we'll always have an O&M contract with them. Our interest is residual income. And then for those that don't have the capital, we'll arrange project financing via a combination of tax equity and debt. But we always want the long-term O&M. It gives us the data to improve our software and add more value going forward.
Go ahead, Dave.
Yeah, it sounds like you have a very competent solution in a fast-growing segment, which is great. But I'm not convinced that you have a great deal of defensibility here. I don't think you can patent the idea of putting a battery underground. Could you tell me where I'm wrong here?
Well, we have a patent. So I think the question is, will that patent hold up if someone copies it and we have to, we have no idea. And so, but the undergrounding of the battery is a lot more complicated technology than it seems really obvious. And those easy, obvious things are the most difficult to install. So our underground battery system, excuse me, we have to put a climate control system in there. We had to change the material so we could make it very lightweight so that any contractor with a backhoe can install it. We also have to design the top so that it's H10 to H20 traffic rating. And so there's a lot of engineering that goes in to just building the structure. But it takes about 4 hours to cut pavement and install that vault. It goes in very quickly because of the size. So that's one side of our technology. The other side of our technology is the hardware to DC couple and provide an integrated solution. There's a lot of competition out there in building those power electronics, but we're in the field all the time and we understand what we need to build and designing the right product. And then finally, ultimately, it's your software. The software in 5 years will be the key differentiator. And that's where, that's where we're focused on. And by just getting the data and making the systems operate optimally, hopefully we'll have enough of an advantage that if someone copies us, we have enough sites and we'll deal with that when that comes. But it is an enormous advantage based on customer feedback. We're just not big enough to meet the demand for the underground storage right now.
Thank you.
John, you want to wrap it up?
Sure. I have a practical question. How do you envision getting this system into the hands of DoD? Do you intend to take contracts directly? It seems like your business really is, a product integrator, which that's often what defense customers like to see. Or do you envision partnering with companies who are more traditionally A&D?
Well, so we have channel partners, and again, we're designing our system. When we say productized, it means we give a blueprint and a game plan so we can scale that very quickly using a DoD contractor or any other contractor to install following our blueprint. I personally don't have any experience with the DoD, but my gut tells me that our next phase is to make our underground storage. It's resilient to water. We want to make it resilient to about 10 feet of flooding and then fire as well. So I think there's application. The fact that you can drive over it and locate it anywhere. We'd like to engage with the DoD to understand their problem so we can modify what we have for a solution.
Understood. Thank you.
You're welcome.
Perfect. Thank you so much from Intertie, Richard Merlick. Thanks, Richard. Up next is Chart and Silicon Systems, and Alan Aronoff, President and CEO, is presenting.
Good afternoon, everybody. Can you hear me okay?
Perfect.
Okay. So Tartan Silicon Systems is involved with improving semiconductor reliability through some of our key IP, integrated intellectual property, and machine learning algorithms. Go to the next slide, please. This is what I'll cover. Let's go to the next slide. So Tartan's been we're profitable from the beginning, and we were profitable because we have some key relationships within the semiconductor supply chain, including ASE, which is one of the largest assembly test houses for semiconductors, also including a company called Galaxy Semiconductor, which makes some some analytical tools for analyzing test data, and also Imagination Technologies, which is an IP supplier into the semiconductor industry. What we do is we provide product engineering and production services, meaning we work with our systems companies who have a need for a proprietary silicon. We help them get the devices into production, and we make sure the devices are produced reliably through reliable supply chains. And through the product engineering services that we provide, two of the things we do is we will improve yield through machine learning based upon the sensors we've developed that are embedded on chips, as well and those sensors include sensors for process as well as for some of the reliability considerations. Our value proposition, we enable our customers to realize high quality semiconductors. We support a complete life cycle of the chip, meaning we monitor the data, we monitor the health of the chip throughout the chip or the chip's useful life. And that information is used with our machine learning algorithms to predict device failure, primarily due to semiconductor aging, which is one of the main failure mechanisms we are now seeing in semiconductors. Next page, please. Okay, so our IP, we have 2 patents that are filed that cover our reliability sensors and also the entire lifecycle management system we've developed. Our focused applications and focused customers are semiconductor types of products for medical devices, enterprise networking, enterprise computing, military, and automotive. These are sort of the high value semiconductor where one of the key elements is if there is a device failure, what does that mean for downtime for the system? If the penalties are high, then, or if the costs are high, then having the ability to predict failure and proactively deal with a potentially failed device is critical. Next page. Next page, please. Let me briefly describe the problem. So in the curve on the left, the blue curve will show what one would see typically as an observed failure in a semiconductor device. Early failures are usually dealt with through burn-in, and then you'll see a flat or random failure mechanism, and then at the end we have these wear-out failures. Now, the wear-out failures are becoming more important because chips that are developed on advanced semiconductor technologies like gate-all-around or FinFET technology, as the devices become smaller and smaller, these wear-out mechanisms, such as hot electron injection, negative bias, temperature instability, etc., are increasing. This, coupled with the fact that devices are designed in these mission-critical applications for longer life, means that wear-out mechanisms and wear-out failures are becoming an increasing problem. The problem is further exacerbated by the fact that through the chip design methodology, wear-out mechanisms, that is how devices will vary in their characteristics, and these variations in characteristics will cause devices to not operate at their spec, hence they're a failure. So to some extent, the industry is flying blind. There are activities underway to address that. We are one of those, our approach in addressing this is through our IP that's embedded on chip with sensors to measure process parameters and specifically measure the wear-out mechanisms, and are able to report those data not only during test and manufacture of the chip, but also during the operating life of the chip. Next page, please.
Hey, Alan, 30-second warning, all right?
Okay, sorry. So basically what our sensors do is they enable us to measure these critical parameters. The sensors are integrated on chip through standard operating procedure, standard design procedures, and we gather the data through the normal way data is gathered through wafer probe, final test, etc. Next page, please. One of our key developments is what's called the enterprise database, where with our sensor, we have a unique ID for each device that identifies location on the wafer and track all the data from wafer probe, final test, and also field data from our reliability sensors. Next page. Next page, please. This is showing how our solution is different from what's out there today, because the ability to track and monitor device health is currently not being done. Although there are people that are working on this, some competitors working on this type of solution as well. Those competitors would include a company like Proteantex, which is an Israeli company that is also addressing this as a big data problem. Next page. So the key executive team is myself and Chakra Parvathaneni, our CTO. We both have a 30-year plus history in semiconductors and semiconductor IP. Next page. So our request, to date, we've been self-financed through NRE engagements. We have several customers that are interested in our technology and deploying it on chip. And we are looking for some money, about $1 million, to build a demo vehicle. That demo vehicle will enable us to instantiate our IP on a test chip. That test chip will also include a set of functional elements like a RISC-V processor and a lot of RAM. So we actually have to find a failure so we can build that into our database so the machine learning can identify failures. We'll fabricate the test chip, create the enterprise database, and develop our failure prediction algorithm. This funding can be either from as investment or strategic partner. Siemens has given us a letter saying they want to contribute to this development. We also have support from Global Foundries to fabricate the test chip in their 12 nanometer FinFET process. And with that, I'll take questions.
Good day. Dave, I think you're still on mute.
Hello.
Sorry. This is Dave Anderson from Mighty Capital. I have two questions. Firstly, I'm guessing that your IP looks at the smallest geometry transistor performance in some sort of dynamic way over the lifetime of the product, but can it detect defects which are essentially random, but are not serious enough to be detected when the chip is manufactured, but later on cause the chip to malfunction?
Yeah, so early on, that's a good question, thank you. Earlier on, I showed a chart, and there are two contributors to failure mode. There's a wear out mechanism, which is accelerating, and then you have a random defect that's sort of a constant failure mode that you might see over the useful life of the device. Our focus is on the end of life failures, especially which are becoming more prevalent with newer technologies, and also with the demand for life expectancies or the useful life of the chip increasing over time.
My second question is that if I understand your offering, you're not really a design house, you're not designing the chips, but you're adding technology to other people's designs. Is that correct?
That's right. We have a silicon block, a little block, which is our IP, which includes a process and reliability sensors that get integrated into the chip. And the other part of our so that IP enables us to create the enterprise database. And then we have algorithms that operate on that database for the purposes of optimizing yield and also predicting failures.
Right. So could it be that you can essentially license your IP and allow and scale more quickly by allowing several companies to integrate the technology?
That is our plan. Actually, from the business model standpoint, we provide services today by doing the yield optimization and working with customers on their reliability issues. But with the IP, the value point is enabling the analysis that could be done on the big database. So we would have two portions to our business model. One is the IP licensing, and then the other side would be the enablement for the big data analysis and the machine learning models we develop for yield and reliability.
Thank you.
Go ahead, Alessandro.
Yeah, actually, that was also my question about the business model that you're adopting. Second question that I have is, what's out of your control that must happen for this technology to reach a mass adoption?
So I think the adoption of the technology is going to come from applications where we're seeing interest in today, which is high-end computing and automotive. And we've also had some discussion on the military side as well. So what we are, the proliferation of our technology will happen once we have the proof of concept that we can demonstrate, which is what we proposed, or which is our proposed ask. So one of the challenges in the market today is this type of solution requires a multidisciplinary approach, and there's not really a company that's addressing this complete solution. So the EDA companies want to build models for simulation. The chip companies want to build PDKs to enable companies to do design. But this whole area of driving and improving reliability and enabling failure prediction, there's not really companies doing that today.
Thank you.
Dr. So you want to ask the last question? We lost him. He froze.
Any other questions?
Yeah, we have Jane. So do you want to ask the last question? Oh, I think he dropped off. Okay. Oh no, he's asking. You're on mute.
Sorry. So if I understood correctly, you're creating this reliability sensor to be incorporated into the chip design. And so are you planning to work with the design, the chip designers themselves, or are you, because a lot of the e-testing happens at the back end, right? And there's some inlines for visual testing that happens, but you're doing more on the wear out testing. And so I would think that a lot of these chip companies already have these sensing and measurements that happen internally with each of the chips. So why couldn't they do what you're doing on their own? They know their chip much better than you do. And so can you talk about that a little bit?
Sure. The larger semiconductor companies will focus on, well, first off, I want to preface this with, we're focused on mission critical devices that are in systems that if there is a failure that occurs, or we'll have a significant cost due to the downtime of the system. And today in the market, the larger semiconductor companies They will do a lot of simulation up front to make sure the device meets spec. There is a new area that's currently coming about where companies are starting to include some simulation models to take into account aging, but that's different from what we're doing, which is being able to measure the health of the chip in the field and be able to predict or notify when some key parameters have moved sufficiently that may cause a failure for some proactive maintenance to be done, replace the chip, replace the system, whatever. So we're approaching it differently. Companies today are not currently putting these types of sensors on chip for purposes of reliability. Some companies will have some process monitors on chip. They use that primarily for dynamic voltage and frequency scaling to enable design to operate at low power. So they're going after a different metric than what we are going after with our IP. Although the design methods for incorporating our IP are very similar to what they would be doing for any blocks and sensors that they would integrate.
Awesome. Thank you so much,
Thank
Alan
you.
Arana from Tardin Systems, Silicon Systems. We're joined by our last presentation of the evening, or the evening for us, or morning for you, good afternoon for others. It's for semiconductors and electronics session. We're joined by Monty Johnson from Sinbet.
Good afternoon to many of you. Thanks for hanging in there. I know it's end of the day for many of you. I'm excited to have the opportunity to present our unique technology, our Interchip, to address low power needs of medtech, IoT, cold chain. There's been years of development investment, and this product is ready to go over the finish line. Next slide, please. Sinbet is the worldwide leader in solid-state thin film battery. We have manufacturing in place in Lubbock, Texas with XFAB. We have strong IP, patents, and trade secrets. The addressable markets are very, very large, and we think we have a very unique solution for the power requirement of these markets. Next slide. Our small size, I'm talking 2 by 2 millimeters, 400 to 10,000 devices on a 6-inch wafer. Our advantage over other solutions is our Interchip can go through solder reflow, which facilitates high volume assembly. It's rechargeable thousands of times, zero cytotoxic, so it's great for medical, and easily integrated into other devices and makes the manufacturing of those solutions easily done. Next slide. So compared to conventional energy storage devices, our size is a key thing, but also the lack of hazardous chemicals like you have with supercaps and coin cells. And obviously they have integration issues as well because they can't go through solder reflow. You have to have sockets and holders. Obviously there's transportation restrictions that may be prohibitive as well, but not with our Interchip. So what is solid state? Why is it important? The electrolyte is a ceramic, not a liquid, gel, or polymer that you find in many lithium batteries. So therefore, solid state means safe, non-flammable. And that also means that it has a high charge and discharge cycle, which is great as well. The key for us is this high density or HD development for our Interchip, where we, in the same size, we can increase the capacity by 2x and 4x. And by doing this, we can substantially expand the addressable markets. Next slide. There's a huge and big expanding markets for thin film batteries. The ubiquity of low power sensors fits well with the Interchip. IoT, medtech, obviously with our biocompatibility, semi-passive RFID, and really a huge area for us that we think can be a huge, huge market is the cold chain, supply chain, and temperature monitoring. Next slide. Biomedical devices, we've been involved with a number of things in ophthalmics, neurostim, and again, it's the physical size, the integratability, and obviously zero cytotoxicity that allows for a number of these things. Now, obviously, biomedical takes longer to get any kind of revenue streams going, but we think that we've already engaged with some, and we think there's some long-term viability there. Next slide. A big game changer is the temperature monitoring solution, which is facilitated by our interchip. We can address billions of units in the cold chain, supply chain, due to the making of a low-cost tag. The key is an end-to-end continuous temperature monitoring and data logging, which is not occurring now. And by having this low-cost tag, we can obviously expand this into cartons, and rather than just on huge pallets. We can get this down to carton level, and we don't have to worry about what happens between warehouses and trucks and other distribution methods. It's flexible, disposable, rechargeable tag. So it's a very interesting proposition with a huge upside. Next slide. As I mentioned, we outsource to XFAB Texas, a worldwide well-known foundry. They have expertise in process, and that's what's really been important for us. Plus, we're in the US, and we think that allows us to protect our IP better. We also have a offshoot product, a real-time clock, power management chip that is also outsourced in terms of its manufacturing to a wafer fab. We have 46 patents in place, but the real value in that IP is the unregistered trade secrets and know-how that we've developed over years with a lot of investment. Next slide. So what we're doing is we're seeking $2 to $6 million. At the $2 million level, we get to get our HD development on a better track than it currently is. And at the $6 million level, that's when we integrate and work with a partner to design a sensor and data logging ASIC. And again, the huge market here would certainly justify a $6 million investment. The tag inlay is a smaller piece of that overall 6 million. But again, the key is this high density development. We get 2x and 4x the energy capacity in the same size battery. Next slide. Our team is very well experienced in technology and high technology. Jeff Sather's on the panel here with me, and he's certainly open to answering any questions. Jeff and Dr. Downey, who's on a lot of our patents, as well as Dr. Rogi, who's part of our team as well. They probably know more about solid state thin film batteries than anybody else in the world. So with that, I'll open it for questions.
Awesome. Any questions for Monty?
Hi, this is Chen. What is the energy capacity that you can hold this solid state thin film battery?
Jeff, I'll let you handle the different sizes we have and what they mean in
Sure.
2x,
Yeah.
4x as well.
Yeah, so in the general range of our battery capacities measures in the tens of microamp hours. And what that means is that we're really structured these devices to be either the main or the backup power source for low power and ultra low power sensors, either as a one-time use battery or more often for a rechargeable version, whether that's for medical devices or small remote sensors that could be recharged with different energy harvesting techniques, for example. But with the trend in semiconductor chips toward lower and lower power consumption per unit function or per feature, we're actually seeing a nice convergence even at these very low battery capacities. And with our ability to put the battery most anywhere, literally, it really is playing well for these remote sensor applications.
I might add that just a 30 microamp hour battery can give 30 days to a low power sensor tag.
Dave, you have a question?
Yeah, so I'm a little confused about the 2x and the 4x energy density. Can you explain, is it one or is it the other, or is it you're hoping for 4x, but it'll probably be 2x?
Right, good question. So the 2x and 4x is, I think, obviously relative to our current legacy products. The 2x is a sort of a stepping stone to 4X, and the reason that we've bifurcated the development there is that the challenges associated with the 4X development, there are some, say, thermomechanical engineering challenges that we have, where we have to do things differently in the wafer process flow in terms of materials and processes in order to achieve 4X. So a 2X is a more readily achievable milestone from a technical point of view, and still gets us into additional markets and applications that we currently can't reach with our, call it 1X technology. And the 4X is a little longer development cycle, but still within say a 2-year time frame.
Okay, well, here's my problem. Symbit's been around for many years. I've looked at your products in the past, and I've been retired a long time. And you're undoubtedly the experts in the field. But I buy into the idea that technology is moving in your favor with lower and lower power sensors. But why, if you're successful with your product offering, and you should be, why do you need to raise money from investors like ourselves if you've had so long to actually make this product do well?
Right. Do you want to handle that, Monty, or should I?
I can start. Dave, thanks for the question. Yeah, Symbit has been around for a long time. There's been a lot of money invested in the process. When we went to high volume manufacturing and our move down to XFAB, we had some issues that we needed to work through. We've worked through all of those issues. I think when we saw the market, and thanks for the point about the markets are moving in our favor, but still by making that 2X and that 4X, that really opens up the market exponentially for us. So I think that's those are the key things. And I think it's just been, quite frankly, you know, it's the investors that we've had, they've been in so long, it's hard to keep their attention to some extent. So that's why we're here in part. Jeff, do you want to add anything to that?
Yeah, I would just say that in the early years, we did actually have to, given that we were pioneers in the development of solid state microbatteries at the wafer level using photolithographic processes and semiconductor type processes with these battery materials. It really was and still is a unique approach to fabricating these devices. And so the development timeline and the costs associated with that, the engineering costs associated with that in the early years was substantially more than we had anticipated. But as Monty said, we've put those, processes and materials and equipment in place at the XFAB facility in Texas. And, now it's a matter, I think, of, advancing the technology to the next level and getting customer traction in these expanding arrays of low power applications.
Thank you.
If I may, a question, Monty, you haven't discussed the competition. Who do you see as your competitor?
Well, there aren't a lot, as Jeff pointed out, there's not a lot of competitors in our particular marketplace. There had been some, they're mostly out of business, or they're using a different process that doesn't allow them to make a battery as small as ours, and frankly, not to get as much energy into our into the size battery that allows these low power sensors to be ubiquitous. Jeff, you want to add to that?
Yeah, I think that the track that we've taken is really to focus on the chip scale batteries that are solder reflow tolerant, that allow for integration and miniaturization of modules. System and package system, I won't say system on a chip, but system and package type applications where space is at a premium, where integration of the power source is critical to the product design, and where the system is operating off of low power. Obviously, our batteries have very low capacity, but it's important that those applications be places where space is really at a premium, and or reliability and safety of the power source is critical. And other others that have gone into the market, they've used similar materials and processes, but not manufacturing techniques, and they focused on somewhat larger batteries that end up being, because of the processes that manufacturing processes that were used by those companies, the cost was nowhere near favorable enough to be feasible for volume markets. So we're really focusing on, in addition to the implantable on-body and in-body medical, we're really acutely focused on high volume markets where the chip scale nature of our battery that lends itself to high volume assembly is really something that brings value to the product and the manufacturing process, the end product manufacturing process.
Awesome. Thank you so much, Monty and Jeff from Symbit. Stay around for any questions that might appear in the chat. And with this, we conclude our final session in the Advanced Materials and Electronics showcase. I just want to quickly thank our panelists from today. You know, you are, but I'll just mention you one last time. From Sky River Ventures, Hyuk-Jin Seo. From Mighty Capital, David Anderson. From Mobile Ventures, Anna Lizer-Rovici. From the United States Air Force, Nathaniel Schaffler. From Prime Movers Lab, Alessandro Levy. Next Year Ventures, Yoav Weiser. John Reifenberg from Sierra Nevada Corporation. From ZF Group, Miranda Watt. Kyle Atkins, who had to sign off a little early, from Full Cycle Climate Partners. Saul Cates from Dallas Cloud Security. From Applied Ventures, Rajesh Ramanujam. And from the DTRA, Christopher Brazier. We heard from 4 excellent companies: Intertie Incorporated, Turing Micro, Symbit Corporation, and Tartan Silicon Systems. And with that, we conclude our 9th showcase of the year. And wishing the rest of you, all of you, a good rest of your day or evening, wherever you're at. And we should all be successful and find the right partnerships and find the right companies in order to make our initiative successful. Take care, everybody.
Thank you very much, Josh.
Thanks, guys.